Tradoon. Tradoon. Welcome to We Sing Dinosaurs. Deinonychus lived in the early Cretaceous period, after Allosaurus and before Tyrannosaurus Rex.
One of the most fearsome hunters wasn't big at all. He measured close to 10 feet long and only 5 feet tall. Deinonychus, with his powerful jaw. Deinonychus, with his terrible claws. When they spied a likely foe, they'd race to the attack.
I actually really like this song.
With his powerful jaw, Deinonychus, with his terrible
This song
claws. His arms were long to hold his prey, sharp claws were used to grip. But the deadly claw was on his foot, the one he used to rip. Deinonychus, with his powerful jaw. Deinonychus, with his terrible claw. He wasn't a big dinosaur, but Will was bound to say he must have been the very fierce hunter on the shore. Deinonychus, with his powerful jaw. Deinonychus,
Well, hello everybody, and welcome back to Paleontologizing. Happy Friday to you! Hope you're ready for the weekend, everybody, or whatever time it may be, whether you're watching live in a different time zone, or in one similar to mine, or if you're watching later on in the VOD or on YouTube. No matter what the case may be, I'm glad that you're here. Welcome to Paleontologizing. Especially if you happen to be new here. Probably got at least a few new folks. Welcome to the channel. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch trying to do some good old-fashioned science outreach. So as a dinosaur paleontologist, I study dinosaur fossils.
Tells us something about how the world was.
Cody Ross, thank you for the follow. Speaking of new people, thanks for following. Welcome. Like I said, my name is Danny. I'm a dinosaur paleontologist. And as a dinosaur paleontologist, I study dinosaurs, I publish on them in the scientific literature, I talk about dinosaurs 5 days a week here on Twitch, and of course I dig up dinosaurs. This past summer, I was able to stream that too, so we were excavating at least 3 new species of dinosaur and a bunch of other cool stuff in Wyoming and Utah this past summer, in June and July and August. So check out the YouTube page if you want to see some videos there of our exploits in the field this summer. It was a ton of fun. Anyway, on today's episode of Paleontologizing, we're going to be doing a lot of viewer Q&A like we always do, so if you've got questions, do not hesitate with those. We'll also be going over some fossil news. We've got some brand new dinosaurs to discuss, and a brand new mosasaur as well. So we'll be talking about that, and we'll be doing a review game later on. Another rollicking instance of Who Wants to Be a Millionaire, or rather, Who Wants to Be a Paleontologist. So we'll see if you all have been paying attention over the past few weeks. It's been 2 or 3 weeks since we've done Who Wants to Be a Paleontologist, so got a lot of questions saved up, and I think it should be a lot of fun today. So yeah. Anyway, before we get into any of that, let me go through chat real quick and I'll say hello to everybody. We'll do some greetings here. Looks like first up we had Kodali. How are you doing, Kodali? Welcome. Lugnudo, glad to have you here. Claire Burr, what's shaking with you? Matt M33, hello. And Jody Fish, good afternoon to you too. Jody Fish, welcome back. Ant Streams, Belent, I hope you're having a great day. I hope you're ready for the weekend. It's good to see you. And Bet Medler. Hello, Bet Medler. Welcome back. Steely Dan, what is shaking with you? I'm glad you could be here today. And Shafed, how are you doing, Shafed? Hello to you. I Hope all's well in your part of the world. Malicia Total, bienvenidos otra vez. Buenas tardes desde Marte. Ay, ay, ay. Malicia, it's good to have you here. Welcome, welcome.
Dinosaurs were the sort of creatures you might think of as inhabiting another planet.
Well, well,
The
well.
kind you dream of in a bad nightmare.
Okay. Executive Storm. Thank you. Holy cow. For those 39 months of support. That is extraordinary. It really is. Thank you, Executive Storm. I appreciate you more than you know. Thanks for keeping me here on the air for all this time. That's brilliant. Otto the Potato, what's shaking with you? It's good to have you here. Chris TS, glad you could make it to today's stream. Fall Machine, did I say hello to you yet? Welcome, welcome, Fall Machine. And Nana Banana Nan, hi to you too. I'm glad you could be here. Grim Deviant, hello, hello. Dinosaur Dave, good morning to you. Down there in Straya, how you doing, Dinosaur Dave? And Barnjeff, what is shaking with you, Barnjeff, aside from those emotes? Hello, hello. And Lily Maraki, how are things going with you? Good, I should hope. I'm glad you could make it today. Ghostly Ghoul, hello, hello. How are you doing, Ghostly Ghoul? I hope you've had a good week, and I hope you're ready for the weekend. Golganek, always lovely to see you, Golganek. Happy Friday to you. Welcome. All right, scrolling down. Guess that Lego fossil? Dinosaur Dave? Maybe. We've got a lot going on today. Go for Fluffernut. Hello, hello. Welcome. Great Sag. How are you doing? All right, and the Lenina. Lenina, I'm glad you enjoyed the cold open video. It's good to have you here. Thank you for all you do, Lenina and Claire Burr as moderators. Appreciate you. Little Pink Pony says, I'm not feeling well. I need a cozy dinosaur stream. Well, you're in the right place, Little Pink Pony. I hope this helps you feel better. It's good to have you here. Hope you're taking care of yourself, drinking plenty of water, and relaxing right now. MavK14, how are you doing, Mav? Welcome. And let's see, scrolling, almost down to the bottom, almost there. Dr. Irrefutable, hello, welcome back. Trappy Jenkins, glad you could be here, Trappy. Hope things are good. And there we go, down to the bottom of chat. Excellent. Feel like we made good time today. Yeah, if any of you, especially anybody who might be new, happens to have any questions, do not be shy with your questions, please. Do not be shy with your questions. Whether you're wondering about something about dinosaurs in particular, dinosaurs are what I work on, or whether you've got questions about broader topics in natural history. You know, you want to know something about a particular non-dinosaur creature. You have an idea about how the Earth has changed over the eons as time has gone on. What is it, about 4.5 billion years that Earth has been here? You've got questions about extinction or evolution or how paleontology works, any of that good stuff, don't hesitate to ask. That's what I'm all about. So yeah, Real Sugar's back too. How you doing, Real Sugar? Welcome. Anywho, we've got some exciting stuff to talk about today, including some brand new dinosaurs. So let's pull those up, shall we? Oh, but first, let me talk. Getting ahead of myself. Talk a little bit about what I did today. This morning, I got up pretty early, like I often do, and I walked to the ferry terminal. Took a boat into San Francisco this morning, and went to go hang out with a good friend of mine, Snail Chaser, who also streams here on Twitch. Try to see him about once a month at least. We grew up together. We've known each other since kindergarten. And he lives in San Francisco, and yeah, don't really get to see each other often enough nowadays. It's nice that he streams nowadays, too. But, anyway, yeah. So we hung out in Chinatown for a while, got some dim sum, that was really nice. And then we went to City Lights Bookstore, which is a pretty well-known bookstore in San Francisco. There's a picture. Oop. That's not a picture. Hang on a second here. There we go. That's what I was looking for. Yeah, City Lights Books. And holy cow, they had a book that I didn't even know was out yet. This, I don't love the title of it. It's a little generic. But it is a book by Gary Vermeer. Can anybody tell me who Gary Vermeer is and why we've been talking about him in the past? Do you remember that name? What's special about Gary Vermeer? And what does he work on? And Fjellheimer says, and Jurmungandr. Yes, we're talking about the new mosasaur today too. Welcome, Fjellheimer. Yeah. Yes. Lenina remembers. Yeah. I went to a talk of Gary Vermeer's a couple weeks ago. Actually, shoot, must have been like a month ago now. Or over a month ago. In Berkeley. And that was really cool, being able to meet him, and I even got him to sign one of his books. Felt a little silly doing that, but, to have a blind scientist sign a book for me, but, yeah, it was pretty cool, nonetheless. And I'm looking for those photos. That must have been a little while ago, huh? Before my Seattle trip. There we go. Oh, whoops. Hang on. Wrong button.
Wow. The land of make-believe.
Sorry, wrong button. This is the button I was trying to find. Yeah, here's Gary Vermeer. And I was in the second row during his talk. He was talking about the ideas in this book. So yeah, let me find you a quick video too. But I'm really excited to read this.
And it's therefore likely that we're here today because, by the luck of the
Hepcat.
draw, dinosaurs who had been dominant over mammals in ordinary times got felled in a mass extinction.
I would agree, Pimcat. Thank you for the 11 months of support. That is extraordinary, and I really appreciate it. Thank you, thank you. Yeah. Here is Gary Vermeer right here.
Evident. I am totally blind and have been so since the age of 3. I never saw very well. I saw colors and so forth, although they made a huge impression, and I still remember quite vividly seeing those colors and what I thought of them. Despite that disability, science has always attracted me. Natural history has always attracted me, and thanks to my parents and brother, who were about as good as one could ever hope to have, as well as to various teachers who were also very encouraging. The key for me has always been careful observation. Now, there are plenty of scientists who have their own disabilities. For example, E.O. Wilson,
True.
the ant specialist and major conservationist ecologist, was nearsighted. Paul Ehrlich, another entomologist, worked on butterflies, was colorblind. My brother-in-law is a meteorologist, Edward Zipser, who is
A meteorologist, just like Alfred Wegener, like we were talking about the other day. himself a meteorologist.
also colorblind, they, like me, overcame these obvious disadvantages, and we took advantage of what we still have left. In my case, the sense of touch and all the other senses that I use. And of course, there are impediments. For example, there is not enough literature easily available in Braille or even in audio formats.
Yeah, true.
But you have to find mechanisms to overcome this. But most important...
And actually, I just found a mechanism like this the other day. Sometimes, I'm often pressed for time. I got a lot of stuff going on, and when I'm streaming between 4 and 5 hours every weekday, and then spending multiple hours getting ready for each stream and stuff like that, it's hard to find time to keep up with the literature and that kind of thing. But I found a couple of neat little resources that I can use in order to be able to, say, listen to a Wikipedia article or to a scientific, paper in a journal. There are extensions that you can get for your browser that will read text to you out loud. So I could be doing the dishes or doing the laundry or cleaning my office, or, I could be out for a walk or something like that. And, it's cool how you can use modern technology like that in order to take the printed word and make it audible so that you can listen to it. So sometimes I'll do that where I'll like, oh shoot, I need to take a shower, but I also really want to read this article. Yeah, I'll just play it over the Bluetooth speaker that I have in the shower, and I can get two birds stoned at once, so to speak. So, yeah. And if I've discovered these things, think of all the cool stuff that Professor Vermeer has discovered in order to be able to make the scientific literature more accessible to him as someone who's blind.
Importantly, you have to use your own senses, and to gain a sense.
And there you go, Dinosaur Dave.
Yeah. As you perceive it. In my case, of course, that is touch, and I've taken advantage of that by discovering all kinds of features of shells that others who are sighted have overlooked, or just simply never bothered to record. It's an entire question,
there you go, little pink pony, yeah.
Careful observation.
They don't want to kill
with
birds.
One's brain in gear, and there's no.
You never want to kill two birds. Well, who would want to do that? Kill birds with stones? What kind of monster are you? No, let's be kind to birds.
No reason in the world why people with disabilities can't do that, despite their limitations.
Yeah.
All you have to remember is that everyone has limitations, and we all have to overcome them.
Good stuff. Yeah, that is Gary Vermeer. And his new book is called The Evolution of Power, and it's interesting because... Yeah. Oh, I guess we've got a video about it already. Shoot. Alright. Enough of the preamble. Let's just get to it.
One among the most prominent paleoecologists and evolutionary biologists of our time. Dutch-born UC Davis Distinguished Professor Emeritus Gerard Vermeer of the Department of Earth and Planetary Sciences. Professor Vermeer has more than 200 publications, including
pretty impressive record.
Books
and let's see. This... Oh, yep, there's a conversation with him there. Excellent. Yeah. Play.
Mean a lot to me. So the word evolution and power lend themselves to many interpretations and evoke thoughts, feelings, experiences, prejudices far beyond the definition of the dictionary. So my question to you is, what is your interpretation of evolution and power? And most importantly to me is, why do you link them together?
Right.
Ooh, this is a great
So,
question.
To me, evolution is mostly, in its broadest definition, in its biological definition, it's a 3-word definition. It is change with modification. Descent with modification, I really should say. It's descent with modification.
And that's funny because that's actually what old Chucky D used in place of the word evolution. Charles Darwin didn't really use the word evolution very much at all. In fact, that word only appears once in the entirety of his 1859 book on the origin of species. In fact, it's the last word in the book. The last word is evolved. But natural selection and descent with modification is the term that Darwin uses, like creatures descending from their ancestors with modifications. That's all evolution really is, you know? Generation by generation, creatures change. It's descent with modification.
I see.
So it's a description. It's not. It implies nothing about mechanism. It doesn't mention natural selection or adaptation, for example.
Yes.
Now, then I distinguish something called adaptive evolution, which is the
Hey, Caledon
descent
K,
with
welcome.
modification, implying that organisms are well fitted to their environment.
Oh, and cool, Hugin. Very nice.
And that
General
too
Science
is a
Podcast?
description.
Cool.
It
Cool,
still
cool,
doesn't
Hugin.
give you the mechanism. So in the book, I argue that a combination of natural selection and agency, by which I mean behavior, response, the organism's modification of its own environment, they both contribute to the adapted state.
Anyway, if you'd like to watch the rest of this, I will give you the link. There we go. Yeah. And Caledon K, we've talked about that before. We've talked about how certain populations of elephants in Africa are starting to evolve. Yeah, how that trait, tusklessness, is now an advantage rather than a disadvantage for many of these creatures. And, yeah. How that, whatever genes are controlling for that, for, you know, diminished tusks or lack of tusks entirely, that gene is spreading throughout the population because it's being actively selected for. Yeah, we watched a couple of videos about that in the past, Caledon K. Yeah, because of poaching. Yeah. Anyway, yeah. We've got a few new dinosaurs to take a look at, and let me see if I can find you those. One of them is a Rabakisaur mimic, and I thought we were going to talk about this yesterday, and I kind of got distracted, and then it slipped my mind. But we have got a brand new dinosaur just published a few days ago. There it is. Yeah. Carrie Woodruff was publishing about the, or was posting about this on Twitter. Carrie is a sauropod guy himself. This is new sauropod day. Welcome, Inowentu Oslatus by Philippi et al. Besides being a complete and articulated skull through the sacral verts, jealous. We were talking about how skulls are really uncommon to find among sauropods. Inowentu is also a Rabakisaurid mimicking Titanosaur. Very cool, and congrats to the authors. And Carrie was a reviewer on this paper. Really, really cool. Yeah. And take a look at that. We've got a skull. This is incredibly rare to have for a sauropod. Super, super cool. Here's the paper here. It is in the journal Cretaceous Research, which means we're probably not going to get to look at the actual paper itself, because unfortunately, Cretaceous Research is... it's not open access. It's paywalled. But give me just a second here, and let me try something. There's like a 1 in 10 shot this is gonna work. No, not today. But, let me see if I can find you a press release on it. They did do a press release, right? No, Google News has got nothing. That is disappointing. That we've got a brand new dinosaur. And it's not made the news, like, at all. Unless you're following paleontologists on Twitter, you're, not gonna see much of it, I guess. Shoot. That's disappointing. I guess the best we can do right now is the Wikipedia article. Inuwentu, whose name means imitator, that is a great name, considering what this critter looks like. It's an extinct genus of Titanosaurian sauropod dinosaur from late Cretaceous Bajo de la Carpa formation of Argentina. The square-shaped jaw of Inuwentu demonstrates convergent characteristics with Rubachisaurids. So we've talked about convergent evolution I don't know how many times on this channel before, but for those of you who are unfamiliar with this concept, let's talk about it a little bit. So, convergent evolution is when you've got unrelated species that develop similar traits or a similar body shape despite not coming from the same ancestor. So it's the opposite of homology, I guess, is convergent evolution, where you can get different creatures that have, maybe they develop a similar body shape, similar anatomy, similar morphology, even though they're not related to each other. So this is a beautiful example. Sharks and dolphins, ichthyosaurs and penguins all have a similar kind of body shape, even though they're all very different from one another. Sharks are cartilaginous fishes. Ichthyosaurs are reptiles. They evolved from land-living reptiles. Dolphins are mammals. They evolved from land-living hoofed mammals. And penguins are birds. They evolved from dinosaurs. And yet, all four of these creatures have evolved for fast movement through the water. And so similar evolutionary pressures have kind of molded them into a similar kind of shape. You've got this fusiform kind of outline, this streamlined, almost torpedo-like shape. Three of these critters have got a dorsal fin, which evolved to help them cut through the water and help stabilize them as they're moving through. I guess that probably helps prevent roll as they're moving through the water. And they've all got flippers. Their forelimbs are flippers, are fins. Either for steering through the water, like in dolphins, ichthyosaurs, and sharks, or for active flapping through the water, like penguins. That makes sense? Convergent evolution is when you've got different critters developing similar traits, even though they're not closely related. And submarines have a similar shape, but not flippers or dorsal fins. Yeah, they opt for propellers instead in aerospace. But submarines do have dive planes, usually aft and stern. But yeah, so this critter, Inuwentu, is a titanosaur, and yet it has evolved a Rubachisaur-like snout. So it's probably doing something very similar. Pretty cool. That is really neat stuff. Remarkable convergent anatomical traits with Rubachisaurid sauropods. Holy cow. The convergent evolution between Rubachisaurids and Clade A members is interpreted as a result of the same ecological niche exploitation. So these guys are eating something very similar to what the Rubachisaurs are eating, and so they evolved very, very similar jaws. This is exciting stuff. This is really, really cool. Yeah. Oh, yeah. Yeah. Christia says plants do this too. Thorny succulents of Africa versus spiny cacti of the Americas is the best example. Yeah, that's a good example too. There's literally thousands of examples of convergent evolution in different critters. It's pretty cool to think about.
Brontosaurus. Big fella, isn't he? 70 feet long.
Azura Darren, thank you for that follow. Welcome, welcome. It's good to have you here. Thank you for joining us. Let's see if we can find a decent video on convergent evolution. Let's see here. There's not that many. Let's try this. Convergent evolution of lizards.
So on each of the islands in the Greater Antilles, the big islands in the Caribbean, there are different species of anolis lizards. There's a long-legged lizard that lives near the ground and runs around a lot. There's a short-legged lizard that creeps really slowly on the twigs. There's a green lizard up in the trees with big toe pads. And there's another lizard in the grass with long tails. The species that use twigs on the different islands, they look very similar. And if you first saw them, you might say, well, maybe they're the same species, or if not that, they must be closely related. What our data show, in fact, is that they're not closely related. The species that lives on twigs in Puerto Rico is not closely related to the species that lives on twigs in Jamaica, or the one on Cuba, or the one on Hispaniola. And the species high in the trees with the big toe pads, the one on Jamaica, is not closely related to the one on the other islands. So in fact, what we found is a phenomenon of convergent evolution.
Yeah.
Species that live in the same environment, that experience the same natural selection pressures, evolved the same anatomical structures. So
pretty cool.
They look alike. So that the species that uses twigs on any of the islands has evolved in the same way to adapt to using those surfaces.
Pretty neat stuff. There are literally countless examples of this sort of thing. And it's just one of these themes that we see again and again and again. It's kind of like, I don't know, a lot of you have probably heard about this, because for whatever reason it just blew up on the internet. But this idea that like, oh, everything wants to evolve into a crab. Which, it's an example of convergent evolution. It's not true. It's like only in select groups of crustaceans. Is there a tendency to evolve into what we would call like a crab shape? But yeah. That is an example of convergent evolution. Yeah. Anyway. Mayor Space says, I have 3 different species of anole in Florida. Only one native to California anole. The brown anoles and the night anoles are invasive transplants from Cuba. Interesting. Yeah. Yeah, cool. Commandant Herder says, can I evolve into a crab? I've got bad news for you, Commandant Herder. Maybe it's good news. I wouldn't want to evolve into a crab. But individual organisms like you and me do not evolve. Evolution only happens across generations. So you're a little bit different from your parents, who are a little bit different from their parents. That's evolution there. One individual creature, an individual animal, an individual plant, those don't evolve.
Because they no longer knew how to love each other. Is that correct?
No, that's not correct. I
certainly wouldn't want our species to end the same way.
Norby.
I mostly lurk, but I hang out here often and just love learning something new every time I visit. Keep up the great work.
I appreciate that more than you know, Norby. Thank you so much. Holy cow. Thank you for saying that. I know there are lurkers here. And I want the lurkers to know that they are appreciated. I especially appreciate when people subscribe. Norby, thank you so much for the 8 months of support. Thanks for keeping me here on the air. Thanks for making this possible. For the chatters and the lurkers alike. Appreciate you, Norby. Thank you. Yeah.
Ontogeny.
Yeah. Gamers Tavern Show says, I love Star Trek, but I also feel it did a lot of damage to people's understanding of evolution. Yeah, probably. I don't know. Maybe that's one of the reasons why I never really got into Star Trek, is that almost everything pertaining to biology on Star Trek is just completely wrong. Like, almost creationist levels of wrongness. Yeah. So let's talk about carcinization, which is like the popular term for like things keep evolving into crabs, which is not really true. Let's talk about that a little bit, because it's a good example of convergent evolution. I feel like it'll be a good springboard for conversation here too. Yeah. Stinky Winky says, so is our physiology much different from humans 2,000 years ago? It's not going to be that much different, Stinky Winky, but there will be things that will be different. Yeah, humans are tricky because a lot of the selective pressures that exist for other creatures don't exist for us anymore. Because, you know, for instance, there are not many creatures that hunt us down and eat us on a regular basis. So, like, predation pressures are not really something that humans experience anymore. Likewise, there's not too many human beings who, I don't know, succumb to things like exposure and stuff like that. At least, like, in, well, I guess it's an unfortunate number of people who do, but that's not really like something that's going to be guiding our evolution. Those are not going to be intense selective pressures that we're undergoing. Yeah. But yeah. We're taller and live longer because we have medicine and better food. Yes, and that's not really evolution in action. That's just, those are not things that are affecting our genes, you know? That's not affecting gene frequency. Like the frequency at which certain genes are expressed in a population, because those genes are selected for, and those genes are what, you know, propagate because they're what allow organisms to survive. It's more like, you know, we're all better fed as human beings than we were maybe 2,000 years ago. It's much easier to have a balanced diet now than it was 2,000 years ago. And people are generally healthier in a lot of ways than they would have been 2,000 years ago. Life expectancy is higher. These are like quality of life improvements. It's not like an evolutionary thing. Does that make sense? That's the reason why a lot of people are taller, is because one of the ways you can get taller, or at least not be shorter, is by having sufficient nutrition when you're really young. Those critical stages of early development. If you're getting enough food, then your growth won't be stunted. You know? That makes sense? Yeah. People 2,000 years ago couldn't DoorDash pizza. I don't think they could even drive to the pizza parlor 2,000 years ago, Jody Fish. In fact, I'm willing to bet pizza was not a thing. Yeah. NSB says, we've essentially changed what evolutionary pressures we would otherwise be under. Yes, there are still some that exist for us, but it's... yeah, it's not like it used to be. Holy cow, is it not? Yeah. And Lil Pink Pony says, does that mean all these minor things have stopped human evolution? They've stopped a lot of the natural selection that humans used to be under. But evolution is still occurring. Like, generations are always going to be a little bit different from the ones that came before. But it's not going to be a directional thing, necessarily. There will still be some selective pressures, but they're not as strong. And also, like a big part of human evolution might just be like genetic drift. Let's talk about genetic drift a little bit. Let me see if I can find you a decent video here. Oh, from the Amoeba Sisters. Let's check that out. These are usually pretty good.
So here's a question for you. Have you ever compared the candy you get on Halloween with your friends?
Ooh, very topical at the beginning of November. Good stuff.
My sister and I, a bit competitive in the sport of Halloween candy hunting, we both had preferences of which kind of candy we hoped to get in our buckets each year. And as for me, I love gummy bears. And every once in a while, someone would have them mixed in a big bucket, and I remember watching with intense focus the hand that picked out the candy, hoping for gummy bears. Getting those gummy bears was always total luck, total chance. Well, unless, of course, the entire bucket they had was actually gummy bears, but that would not be luck. No, that would be pure bliss. But that's never happened to me yet. So why bring this up? Well, what if instead of candy, we were talking about insects, and they weren't in a Halloween...
Yes. Don't you love when you get insects for Halloween when you're trick-or-treating? Just get a bunch of beetles plopped into your Halloween bucket there. I know I do.
Bucket, because that
You got a rock? Weird adult. Was it a cool rock?
And when you're scooter riding through the neighborhood on Halloween to collect candy, because scooters may or may not be our super awesome childhood mode of transportation, you squash some. Accidentally, of course, because you like insects overall. Were the ones that survived better adapted? Did they have some special ability to foresee events or to move your scooter away from them? Well, assuming they were all just there on the sidewalk in the path of your trick-or-treating, then no. In this random event example, the survivors were not better adapted. They were lucky. It was chance. And the ones that were squashed were, in this case, at the wrong place at the wrong time. And that's what genetic drift is. Genetic drift can change allele frequencies in a population. Remember, alleles are a form of a gene, but genetic drift is random, unlike natural selection. Recall that in our natural selection video, organisms that have traits that result in high fitness are able to pass those alleles on to their offspring. This is where that survival of the fittest comes into play, but not genetic drift.
Yep, and so this is what I'm talking about with human evolution nowadays, is that, like, we don't have that many... let me say we have fewer sources of natural selection on us today. There's not very many critters that are running down the street and choosing which people they're going to eat. Yeah, like, it's much less common for people to not be able to pass on their genes because, I'm not getting enough food and so I'm not fit enough to reproduce, or something like that, It's like a lot of when humans kind of like change the world to the point where it's comfortable for us to live in, there's not much natural selection that's going on for us anymore. There's still a few things. A lot of the changes that like human populations will undergo are going to be the result of genetic drift. Does that make sense? Yeah.
Genetic drift, the organisms aren't necessarily more fit. They just have won the game of chance. So let's look at a representation of genetic drift known as the bottleneck effect.
Godzilla. Thank you, Lil Pimp.
I always like to remember this one by focusing on the word bottle. Well, let's say that we have a bottle here and we fill it with our Halloween candy. If we shake it out and we only get a few of the candy pieces, does it necessarily represent the whole bottle as far as the candy frequencies you got out? Nope. In fact, one of the types of candy pieces isn't even there. That type is totally eliminated. We'll consider a natural disaster, such as a forest fire. The surviving organisms weren't better adapted. They were likely just in an area where they weren't directly affected. But the survivors don't happen to represent the original population, so there's definitely going to be a new allele frequency among the surviving population.
Does that make sense?
Bottleneck effect. Another time to see genetic drift is when you're talking about the founder effect.
And Neil says, do you think the last major ice age played an important part of evolutionary pressure on humans? I don't... So this is outside of my realm of expertise. I don't know. I'm not a paleoanthropologist, and I know, honestly, very little about the particulars of human evolution over the past, 500,000 years. But I do know that we did undergo a bottleneck, an evolutionary bottleneck, in which I think it was shortly before humans left Africa for the first time. Human population dropped precipitously to the point where, like, It was only a few hundred or a few thousand individuals, something like that. There was a big bottleneck event there. That's one of the reasons why humans today are so genetically similar to one another. There's honestly very, very little genetic diversity among all the people all over the world because, you know, I think it was a few 100,000 years ago, there was a big old bottleneck there. Human population dropped really, really low, and so we are all the descendants of those few, I think, 1,000 individuals in East Africa at the time. That might have actually had something to do with that big volcanic eruption. But I'm not totally certain about that. I don't even know if we have a really firm grasp on what caused that bottleneck. But yeah. And so this would be ancestral Homo sapiens, and I think descendants of which may have also been Homo neanderthalis, murderous squirrel, but I'm not totally sure. Yeah. But yeah. Anyway, let's continue.
Another time to see genetic drift is when you're talking about the founder effect. In this case, you may have organisms that have founded an island or some new area. The few organisms that arrive to start a new population do not necessarily represent the original population that they came from. Let's take a case where maybe some seeds that are dispersed by wind end up in a new area that happened to be one that was
I don't know what the threshold is for a bottleneck, Steely Dan. That's a good question.
Grows.
Yeah.
Well, those seeds that landed in this new area may not necessarily represent the original population of plants from which they came from. It's a random sample. Founder effect.
And Jason FC4. Thank you, Jason. I appreciate that very much. Thank you, Jason. Holy cow, I appreciate your generosity. I'm sure Gary and Kellis does too. Won't have to watch those ads anymore. Good stuff. Jason says, enjoy the ad-free viewing. I appreciate that. And I know Gary does too. Good stuff.
In summary, genetic drift can make some big changes to allele frequencies, and it's a mechanism for evolution.
Yep.
So one last thing. Which type of population do you think would be more vulnerable to genetic drift?
Ooh, good question.
A big population or a small population?
What do you think, chat? Which one would genetic drift be a bigger factor in? A big population or a small population? Any ideas? Any ideas? The answer is small population, as you'll see here. It takes a lot less to change a smaller population and to get genes to spread far and wide in a small population than a big population.
If someone is just doing some intense candy hunting and by accident scooter rides over a few insects, look at the results in the small population versus the big population. As you can see, this random event has the potential to cause more change from the original in the small population.
Yep.
See, there weren't as many representatives there in the first place. So in many incidences of genetic drift in populations, the impact on small populations is especially significant.
Yep.
Well, that's it for the Amoeba Sisters.
So good stuff. I'll give you this link, but if we go back to our example with the lizards on those different Caribbean islands, those are all small populations on islands. And so whether it's selection or whether it's genetic drift, with smaller populations, it's easier to kind of change the whole, change gene frequency across the whole population because you don't have as many organisms there. You don't have as many individuals. Yeah. So anyway, yeah. And let me catch up to chat here. Patton Tanker, how are you doing? Welcome to Paleontologizing. Is that in reference to George S. Patton, the American World War II general? Patton Tanker says, the theory of evolution is invalid. What do you mean? Evolution is a change of kinds? A fish into a person, etc. That's not what evolution is, Patton Tanker. You're incorrect about that. I'm not sure why, but you've been misinformed about this. There are no examples of evolution. Adaptation in animals. Oh, so these are like typical creationist talking points that you've... Patton Tanker, here. I'm glad you're here. Please don't run away. let's talk about this. Let's clear up some of these misconceptions, all right? Because whoever told you this did not know what they were talking about. So let's get into that. What is evolution? So evolution is change over time from generation to generation. We've got literally millions of examples of this happening. From things like studying fruit flies or bacteria in the laboratory over a really, really short amount of time, watching those generations evolve, like watching, changes happen from one generation to the next in the laboratory, like in a human timescale, so we can actually watch this happen, to going into the fossil record and literally watching one species of dinosaur evolve into another over time. We've got lots of examples of this kind of thing nowadays, and that's really, really exciting. Shoot, when I was a kid, we didn't really have many examples of like one dinosaur species evolving into another and an anagenetic lineage. And nowadays, we've got a few. We've got a growing number of those, which is pretty cool. Let's see. Here is a classic example right here. We've looked at this many times. But we can see this in Triceratops, where when you look in the Hell Creek Formation, you can basically watch one species of Triceratops at the bottom of the Hell Creek, Triceratops horridus, evolve into what we call Triceratops prorsus at the top of the formation. Now, before anybody actually put these in order and very carefully studied, before anybody was really, really careful to actually put all of these into their proper time context, line them all up properly, we thought that there were two species of Triceratops living side by side in the Hell Creek. Nowadays, we recognize all these ones are down at the bottom and all these ones are up at the top. And now we can watch them evolve over time if we line them up, and we can see these nasal horns grow and grow and grow. This is a beautiful example of evolution. And small changes like this, because this doesn't seem like a huge change, right? It's just, evolution among the genus Triceratops, I guess you could say. But cumulatively, over time, these little changes like this turn into big changes. And that's kind of the story of the history of the dinosaurs. As we can watch these grand evolutionary transitions take place bit by little bit. Cumulatively like that. That's a tricky word. So yeah. Does that make sense? I hope it does. Yeah. Yeah, anyway. Let's see. Anakin Gabriel says, this may be a more philosophical question. How does evolution account for something like humanity is doing, like a small group of individuals are able to achieve things that change and benefit a much, much larger group? Would that be something in inclusive fitness? I don't understand what... I'm not sure I understand the question, Anakin Gabriel. Yeah. So, that's not really something that's within biological evolution, I guess. Like, unless it's affecting gene frequency over time, like which genes are passed on and which aren't, it's not really gonna be under the umbrella of evolution, if that makes sense. Does that make sense? Yeah. But yeah. And Little Pink Pony says, so Homo floresiensis would be genetic drift? Species are not genetic drift. Genetic drift is a process, Little Pink Pony. But no, that would be an example of... That would probably be an example of selection. Homo floresiensis is this small species of hominid. Sometimes called the hobbits. And they were pretty small. We've got fossils of them from the island of Flores in Indonesia. And this was a population of humans that got to this little island and then grew to be really small. because this is what we call island dwarfism. We see this in other groups of organisms as well, where like the, let's see, the dwarf elephants from Catalina Island off the coast of California. The pygmy mammoths, like this, are an excellent example of island dwarfism, where a species gets to a small island and suddenly the ones that are smaller are the ones that do better and reproduce more, and so the whole population ends up getting smaller and smaller over time. Because being small is being selected for. Natural selection is like, yes, smallness, good. The individuals that are a little bit smaller, because, you know, everybody's a little bit different, the individuals that are a little bit smaller do better.
As a former creationist, raised fundamentalist Christian, thank you for this channel. I can finally fill in the gaps in my education that I should have had years ago.
Thank you for saying that, Might Shiny. Thank you most sincerely for saying that. I really appreciate it. I have a similar story in my life. I may have had a similar background. I'm not going to say a lot about it right now, but I'll say that. So, Might Shiny, I'm really glad you're here. I'm glad you're able to escape from that. And welcome to the channel. Yeah. Good stuff. Yeah. Anyway. Yeah. And let's see. Buffalo Safari says, can a big mutation happen? Big mutations tend to not work very well. Yeah, there's this idea called hopeful monsterism, which, yeah, it's like you've got an individual that's got like a really crazy mutation, and we used to think that that is how evolution can happen really quickly, where like you have a creature that's just born with fins or something like that, and you know, and then it can immediately swim in the water, and then that's what turns out that sort of thing doesn't actually happen that way in nature at all. So big mutations just kind of tend to break the embryo, so it doesn't really survive. The hopeful monsters are, they're not what drive evolution. No. But yeah. And Tannerima says, somewhere I read that there was actually more time between T-Rex and Triceratops than T-Rex and an iPhone. No, T-Rex and Triceratops lived at the same exact time. Tyrannosaurus ate Triceratops. We have direct evidence of this. Bite marks of T-Rex on Triceratops. You probably heard it was T-Rex and Stegosaurus. That is true. There is more time separating T-Rex from Stegosaurus than there is separating T-Rex from iPhone. Or Android phone. You know? Yeah. Pretty cool, right? Yeah. And Island Hobbit says, there you go, Special Agent Fox Mulder, FBI. Welcome to Paleontologizing. Here, it's good to have you here, Special Agent Fox Mulder, FBI. I hope you stick around. Anyway, scrolling down. Anyway, yeah. I guess we're gonna have some, like, Evolution 101 right now, because that's what the people want, so let's do that. As somebody, as a paleontologist and someone who studies evolution, I'm always really, really frustrated by... I'm not frustrated with the people themselves who don't understand evolution. I'm just really frustrated that this sort of thing is not taught properly in school. Especially here in the US. It's really shocking, honestly, how the fundamental principle of biology, one of the fundamental principles of all science is so poorly understood by so much of the general public. And here is a figure from a 2005 paper where the researchers surveyed people in these 34 different countries, and asked them, like, do you know about and do you understand and accept that living things change over time? Like, how accepting are you of biological evolution? Iceland, up here. See that big blue bar? They were the highest on this list. It was like over 80% of people in Iceland understood evolution. Can you find the United States on there? Moonrise Rabbit, thank you for the 5 gift subs there. I really appreciate that, Moonrise Rabbit.
_rabbit just changed
Thank you.
with those 5 gift
Thank you.
subs.
Really appreciate that, Moonrise Rabbit. Thank you very, very much. Yeah. Good stuff. Good stuff. Yeah. Have you found the US on here yet? We are way down here. It's about 41% of Americans in 2005 who were surveyed thought that evolution was a thing. So at least we beat Turkey, I guess. But, yeah, we are miles behind other countries like Poland, Bulgaria, Latvia. There's a lot of reasons for this. Some of them are that religious fundamentalists fight tooth and nail to keep evolution out of school textbooks, and they've been largely effective in doing that, unfortunately. Honestly, the point is to keep people ignorant. And they've largely succeeded in doing that. But also, to take some personal responsibility here, we scientists have not been doing the best job of reaching out to the public and in showing them what we've learned and sharing our discoveries with the public. We've not done a great job of that, honestly. Yes, we're fighting an uphill battle. And yes, there are powerful forces arrayed against us, but we could always do better, you know? I think one thing that scientists sometimes really struggle with is communicating the joy and wonder of science with the general public. I think a lot of people in the general public have this idea that science is this stuffy, hoity-toity, dry, boring discipline. And it is not. It absolutely is not. The most passionate, animated, driven people I have ever met are all scientists. Every single one of them. And it makes perfect sense. You know, when your whole reason for being is to learn about the natural world and to uncover the majesty and brilliance of the world around us, to help unravel these mysteries and to make new discoveries, how can you not be passionate and excited? So that's a big part of why I'm here on Twitch. This is why I'm doing this, really. You know? So yeah. Yeah. Anyway. Let's see here. And how is Canada not included? I'm not sure, Jedi Mega Man. Is Canada not on here? I guess they're not. But I'll give you a link to that study. There we go. Public acceptance of evolution. There we go. There you go. Yeah. B. Spielberg 2 says everyone agrees it's consensus settled science. Could you rephrase B. Spielberg? I don't understand what you're saying. If everyone agrees, that makes it right. No, that's... What you're describing is the opposite of science, B. Spielberg. Science is not a democracy. Science is built on evidence. And it's built on falsification. Here's the cool thing about science, is that if someone has a hypothesis, it doesn't matter how popular that person is, how persuasive they are, doesn't matter how many other people they've convinced that this is true. If someone comes up with evidence that contradicts that disproves it, bow, there it is, gone. Destroyed. That's how science works. And again, this is the reason why I do this sort of thing, B. Spielberg, is because people have got major misconceptions about how science works. So as a working scientist, I feel it's my duty to, you know, to help people understand this kind of thing. Yeah. And Gamers Tavern Show, you're absolutely right, yeah. Academia loves nothing more than yell at one another about how they're wrong, yes. B. Spielberg, if you'd ever been to a scientific meeting, shoot, you would understand. It's very, very difficult to get two scientists to agree completely on, like, anything. The way that science moves forward is by disproving old ideas. It's very, very difficult to prove something in the positive in science, especially if it's like a big idea. You just try very, very hard to disprove it, and if everybody tries very hard to disprove something for decades and they can't, if no arguments can be brought to bear in order to disprove an argument, well, maybe that's because it's true, and that's how scientific consensus forms. It's like a battle of attrition in some ways. You know? Yeah. So anyway, yeah. And Tannerim says, have you watched that new Spielberg documentary on Netflix about this topic? Spielberg documentary on Netflix. Oh, do you mean Life on Our Planet? Yeah. I don't think Steven Spielberg really had much to do with that, honestly. He was like one of 9 different executive producers or something like that. But yeah, but no, it's good. Yeah, Life on Our Planet, good stuff. I've got a few quarrels with it, but by and large, you know, I don't want to be too critical. It's pretty excellent stuff aimed at a general audience, which is really cool. And the fact that it's on Netflix makes it really accessible, and I think that's really important. Yeah. Anyway, yeah. And but yeah. HD and HB, you're right. Yeah, we did just talk about plate tectonics and the asteroid impact, how they were looked upon with great skepticism by most scientists in those fields when those ideas were new. But that's the thing, is that it really doesn't matter. In the long run, if more evidence accumulates, there's no stopping it. If an idea is true, if there's some way that the universe actually works, and at first this idea is proposed and at first a bunch of scientists disagree with this idea, like, okay. Over time, though, if it's true, it will be accepted by, I guess you could say, a general consensus of scientists over time, because that evidence will continue to accumulate. And like we talked about with continental drift the other day, sometimes science progresses one funeral at a time. Sometimes the older generation refuses to accept a certain idea, and you just kind of have to wait. I think this is more true in other fields than it is in science. Scientists, we are we are trained to accept new evidence when it arises. But we're still human beings, you know? So I feel like, you know, if we were talking about philosophy or law or theology or something like that, I think those fields 100% change one funeral at a time. Science does maybe a little bit, but a lot less than other ways of knowing like that, you know? Oh yeah, yeah. Anywho, yeah. And B. Spielberg says funding drives scientific consensus mostly. What funding, B. Spielberg? What funding? Holy cow. I wish I had funding. Believe me. I really do. It's only because of this community here on Twitch that I'm able to make a living doing science. I understand, maybe, B. Spielberg, that you've got some sort of idea that you picked up from somewhere. People have fed you this idea, expecting you to believe it. They're like, oh, scientists are just these fat cats sitting in our laboratories, just gobbling up all of these public funds. And then that dictates, you know, what our research findings are. And we laugh to ourselves, ha, 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 ha. Ah, the gullible public will never know. Like, I'm just doing this for the funding. Do you really think that's true? It's like, I don't even know where to start with that. As a dinosaur paleontologist, I've been out on field crews before where we've been out digging up dinosaur fossils, and we've literally had like $400 as our budget for the entire summer. Sometimes we've had close to zero budget, and everybody just had to pay out of their own pockets. Funding for science, especially here in the United States, is abysmally low. I mean, honestly, that's one of the reasons why people like climate denialists get so much traction, is because they have literally hundreds of millions of dollars from fossil fuel companies in order to just say whatever the fossil fuel companies want them to say. But if you're a paleontologist and you're studying climate change in the fossil record, good luck getting funding. Holy cow. But if you want to sell your soul to the oil companies, they will gladly shell out millions of dollars in order for you to be able to say whatever they want you to say. I mean, don't just ask me, ask literally any other scientist, B. Spielberg. Yeah. Anyway, yeah. But yeah. Jody Fish says funding for science in the U.S. is laughably negligible. Yeah. Compared to the scientific advancements going on? Absolutely. Yeah. Yeah. Anyway. But yeah. So anyway, let's get into what is evolution. We've watched this video before. This is pretty decent. Sorry, that's too loud.
Stated Clearly presents. What exactly is evolution?
And this is animated. It might seem a little bit corny, but this is good stuff. And if I notice anything that doesn't quite jibe with my understanding, I'll try and call it out, and we'll also be looking at some examples from stuff like this too, I suspect, as it pops up.
In biology, the theory of evolution doesn't tell us exactly how life began on Earth, but it helps us understand how life, once it came into existence, diversified into the many incredible forms we see now and in the fossil record. It also helps us make sense of the way in which modern creatures continue to adapt and change today.
Yep.
In biology, Evolution can be defined as any change in the heritable traits, those are physical traits like fur color in mice, spots on the wings of butterflies, or instinctive behaviors like the way that dogs greet their friends with a sniff, within a population across generations.
So like I said before, evolution is not something that happens with individuals. You, as a human being, or your pet dog or cat, or the butterfly you see going past your window, that creature is not evolving. Evolution doesn't happen on an individual level. It happens across generations. So evolution is just one generation being a little bit different from the one that was before it. That's literally what evolution is. And those have to be heritable traits. These are things that can be passed down from one generation to the next, in terms of genes. That's what evolution is. Does that make sense? Yeah. So, Twalris says Pokemon set back the understanding of evolution to the public by like 20 years? Maybe. Yeah, because the things that, when a Pokemon evolves, that's not evolution. It's not evolution at all. It's not how evolution works. That would be ontogeny. There you go. Yes, thank you, Lenena. Perfect timing. Ontogeny are the changes that happen when an organism changes throughout its lifespan. So like a frog going from an egg to a tadpole to a frogling to an adult frog, that's changes in ontogeny. That is not evolution. So Pokemon lied to you, I'm afraid to tell everybody. I'm sorry to tell you. I'm not afraid to tell you, but it is unfortunate. Pokemon lied to you. Sorry. Anyway, yeah. But Charizard is ontogenizing. Doesn't really roll off the tongue. Actually, I don't know. I think that sounds cooler. But just because, it is evolving sounds like fingernails on a chalkboard to me, because that's not how evolution works, Yeah. I don't know. I think it sounds cool. Yeah. A metamorphosis. Yeah, when we're talking about frogs or we're talking about butterflies, metamorphosis, that's the term that we use for those critters. But that metamorphosis is a change in ontogeny, Yeah. Yeah.
This definition can be a bit confusing, so let's see how it works. All healthy living things, from single-celled amoebas to flowers to dolphins, are capable of reproduction. We have children, we make copies of ourselves.
Yep.
We do this by duplicating our DNA and passing that DNA on to future generations. DNA is a chain-like chemical stored inside each one of your cells, which tells them how to grow and function.
Yep. Hanny says metamorphosis is the weirdest thing in biology to me. It is pretty cool and weird, yeah. Yeah. Yeah, and Steely Dan says it does seem like the use of the word evolve in many contexts and language sort of dilutes its specific biological meaning. Agreed. Also, the word theory. Don't get me started on that. Maybe we'll watch a video on that next. But yeah, the use of the word theory to just mean like any wild idea. It's got a very specific definition in science. We'll talk about that.
Your DNA contains coded information on how to build you. The information in your DNA is different than that of, say, a daffodil's DNA, which is why you look and function differently than a daffodil. The information in your DNA is slightly different than that of Elvis Presley, which is one of many reasons you don't look or act quite like he did.
True. And Moosey Fate says, does science evolve since it advances one funeral at a time? No, not in an evolutionary sense. I would not say that science evolves, because evolution requires like heredity and passing on of genes and selection like that, and we don't really have that in science. Like, science is a concept and it's both a body of knowledge and a way of looking at things, and it's like a human activity. So it's, we're comparing apples and fighter jets here. It's like they're very much not the same thing. Yeah. And Hanny says, what about epigenetics? What about epigenetics, Hanny's? Yeah. Who's the person to ask about that, or the people to ask, would be Science Streams, Belint and Lita. We might raid into them later, and you can ask them all about epigenetics, because that's something that they actually study. Like, that is the papers that they publish are on epigenetics. And so epigenetics are basically supposed to be like heritable non-genetic changes, but it's kind of more minor than you might expect. Like, the most important things are coded for by genes. Epigenetics is basically like, it changes how those genes are expressed in offspring. So it's not like there's some sort of mysterious, mystical force that's non-genetic that like creatures inherit, and it's not like that. It's basically like epigenetics is kind of like the icing on the cake. It's like just something that kind of goes over the genes. And like kind of it doesn't, from what I understand, and we'll have to talk to Balint about this later, and hopefully Lita will be on too and give some input here. But epigenetics basically is like how does the genetic code, like how is that expressed in the organism? So like you've got the computer program written, but this is like alters how it behaves a little bit. That's a bad example. I don't know. I'm not a geneticist myself, so I'm kind of flailing around a little bit here. I am at the very limit of my ability to explain this because I don't understand it all that well. Because, I'm a dinosaur paleontologist and not a geneticist. This is the thing, that when we're dealing with complex scientific topics, no scientist is going to be an expert in everything or will be able to even explain certain concepts all that well. That's what we're running into right here. So, yeah. Let's continue.
Celled amoebas and other simple creatures reproduce by copying their DNA inside their guts, moving both copies to either side of their body, splitting in two right down the middle, and then growing back to full size. If all goes well, the two new amoebas will be exact copies of each other, but in nature, things aren't always perfect.
Nope, there's replication errors there. That's the basis of evolution.
Errors can occur, which modify the DNA code.
Yep.
This is what we call a DNA mutation. These mutations can produce variation in the body shape and function of the creature who inherits the modified DNA. In this case, our new little friend has an arm that stretches extra long. If he survives long enough to
that
grow
pseudopod.
and reproduce, that extra stretchy arm, which is now coded for in his DNA, will be passed on to his children.
There you go, that's heredity.
Evolution. Any change in the heritable traits within a population across generations has officially occurred.
Yep, there you go.
Reproduction for dolphins and badgers and people is a little more complicated. We have to find ourselves a partner. When two badgers get together and, fall in love, a sperm cell from the father, which contains a copy of half of his DNA, only half, combines with the egg cell of the mother, which contains half a copy of her DNA. The result is a brand new cell with a complete set of DNA instructions, all the information needed to divide and grow up into a brand new badger. The new child matures to be similar to her parents, but also unique because she develops some traits from her mother's DNA and some from her father.
Yep.
Her new combination of traits can be passed on to her children, and again, evolution. Any change in the heritable traits within a population across generations.
So there you go.
That is occurred.
Wow, evolution. So yeah, what he's talking about here is like combination of different traits from the mother and father here. But also you get mutations as well. And you can get things like like recessive traits that are, don't really show up like in the external aspect of these animals. They get passed on and stuff like that too. So it's, there's lots of bits of nuance and detail here, which are really interesting also. But he's just trying to give a really, really simple overview here.
Besides the unique recombination of her parents' traits, she might also have developed some completely new traits of her own due to DNA mutations. Maybe extra hairy ears, for example. If she survives long enough to have kids, her DNA will combine with the DNA of her partner, and she'll pass on those extra hairy ears to at least some of her children.
Yep.
Again, evolution has officially occurred.
There you go.
So there you have it. Evolution is really pretty simple. Scientists and normal folks everywhere witness evolution happening all the time.
It's part
Small
of our
changes
everyday
like
lives.
The ones we've seen here.
So if you are or know of a farmer or a rancher or anybody like that, they kind of understand some of these things implicitly because this is something that they observe literally all the time. You know, different traits arising, and say you're breeding cattle or breeding dogs or something like that or whatever. This is the sort of thing that you have to understand in order to be successful in that and to actually know what kinds of offspring you're going to get, like what their traits are going to be.
Ontogeny.
Yeah.
Here can add up over multiple generations to create dramatic changes. If you were to go back in time just a few thousand years, you'd find that all dogs, for example, originally evolved from an ancestral group of gray wolves. The evolution of those wolves from generation to generation was guided by humans. People were selecting wolves with the traits they liked, letting them breed, and then only keeping the puppies with the most desirable traits. As time went on, different breeders preferred dogs with different features. Some selected for large size, some for small size, some for brains, others for brawn. Today, wolves have branched out into hundreds of breeds, very few of which look and behave much like their ancestors. A massive amount of observable evidence from many different fields such as genetics, chemistry, paleontology, and mathematics overwhelmingly suggests that just like all dogs share a common ancestor, all living things, me, you, pufferfish, banana trees, if you go back far enough, also share a common ancestor. We are literally related. We don't know what the first life form was or exactly how it came to be, but the simple process of reproduction with variation over billions of years looks to be responsible for all the diversity of life we see today. Now, you might be saying, wait a minute, hold on here. Isn't evolution random? To do something functional like turn a wolf into an adorable mini poodle, random evolution had to be carefully guided by an intelligent dog breeder. Researchers claim that all mammals evolved from an ancient shrew-like creature, but the difference between a shrew and an elephant is far greater than that of a wolf and a poodle.
And it took a lot longer too.
Who was the breeder?
Natural
In the
selection.
mid-1800s, two men, Charles Darwin and Alfred Russel Wallace, independently discovered that a breeder is not necessarily needed. There is another force capable of guiding random evolution to produce order and complex function.
This is something that we've seen again and again and again through both observation of the natural world and through direct experimentation in the lab, too. This is really exciting stuff.
They called it natural selection, which happens to be the entire topic of our next video. But before you move on, let's recap what we've learned so far. Biological evolution is any change in the heritable traits within a population across generations. All healthy living things can make copies of themselves, but they do so imperfectly. Small variations can add up over generations to create dramatic differences in the body form and function of living creatures.
Yep. Yeah, SB says, did wolves eat all the humans that wouldn't breed dogs the way they wanted us to? SB, I don't think that was the case, but it's conceivable it could work that way under different circumstances, I suppose. Yeah.
Evidence overwhelmingly suggests that all life on Earth is related.
Yep.
So remember, next time you invite family and friends over for a holiday feast, you're actually just inviting family. That includes the turkey and the pumpkin in the pumpkin pie.
True.
I'm John Perry, and that's evolution stated clearly.
Beautiful video here. Really, really good stuff. And here is a link to it in the chat. That's definitely deserving of a thumbs up. Oh, I already thumbs up it a long time ago. Geocastaway.
Geocastaway has arrived with 2 raiders.
Welcome to Paleontologizing, Geocastaway. How are you doing? How was your stream? I hope it was really good. Welcome back to Paleontologizing. Yeah. Doing some science and technology. Very nice. I can relate. Welcome, welcome. Yeah. So we're talking about evolution right now because there are some people in chat who had some misconceptions about it. And what am I even here to do if not to help clear up misconceptions about the things that I study? So, having fun doing this. Yeah. And it was great talking about geology. Very nice, GeoCastaway. Very nice. Yeah. And by the way, did you know it was Alfred Wegener's birthday 2 days ago? We were talking all about that, talking about continental drift, plate tectonics on Tuesday? Wednesday. Wednesday? On Wednesday. Yeah. Anyway, very cool. What kind of geology were you talking about, GeoCastaway? I want to hear about it, if you wouldn't mind sharing. Let's see. Let's see here. Let's take a look at a clip here from this court drama thing. Given that this is important stuff, and I think there's people here who appreciate this. And Alfred Wegener, great. Oh, nice. We talked about latest news. Very nice, GeoCastaway. Super cool. I'm glad you had a good time. I'm glad it was fun. Yeah. And Steely Dan says, heck, I didn't realize that gene inheritance upon reproduction was considered just as much a part of evolution as random mutation. So I learned something too? Excellent, Steely Dan. That makes me really happy to hear. It really does. Good stuff. Good stuff. It's good stuff. Here, let's talk a little bit about... Well, actually, we haven't seen this video before. Let's take a look at that. From PBS Eons, they always do good stuff. Let's take a look at this. How evolution works and how we figured it out.
The story of life on Earth is a story of change. Living things have changed the atmosphere and the climate. They've endured the movements of the continents and the rise and fall of the seas. And they've responded.
And by the way, if you want more information about this and you want it in a really entertaining way, maybe this weekend when you're not watching Paleontologizing, I'd really recommend that you check out, if you have Netflix, Life on Our Planet. It's this new documentary on there, which is pretty decent, in my opinion. And it kind of endeavors to give you a broad picture of the history of life on Earth. They do a pretty good job of it. There's some things I would have changed. Their dinosaur depictions are not the greatest. But they're not bad. But, the point is to, like, show you this grand pageant of life on Earth. Broad picture. From the very beginnings of life to the present. Yeah. It's also very entertaining.
This is the story of life on our planet.
Very cool. Yeah, good stuff. Good stuff. But yeah, check it out. I got all the way up until the end of the Permian mass extinction, and that's all the time I had to watch it. So I'm looking forward to watching the rest of it this weekend, I think. So far, it's good. Yakuzik says, cool. I'm getting a tattoo of the continents in the Triassic right now. What, you mean right now? As we speak, you're getting that tattoo, Yakuzik? Like, Like this? Let me go back to the Triassic. Let's try 220 million years ago. Like that? That is... Yes, indeed, in my living room. Very, very cool, Yakuzik. Well, that is really, really neat. I hope we've got some good reference images, and hope it doesn't hurt too much. But that's pretty awesome. I gotta say, respect. Very cool to have Pangea tattooed on. Can I ask where you're getting it tattooed on you, if that's not too personal a question? Is it on your bicep? Is it on your back? Is it on your forehead? Where are you getting it? Yeah. Lying on the table watching Paleontologizing. That's really cool, Emilith. That's really cool, actually. And I'd love to see a picture of it if you wouldn't mind sharing it in the Discord. That would be super awesome. Yeah. And Lenina says Blue is getting a tattoo on Tuesday for his birthday. Very nice, Lenina. Very cool. Can I ask what he's getting? Yeah, in front of my lower leg. That's awesome, Yakuzik. That's awesome. Well, I hope it goes really well. Neat stuff, and that's going to be a great conversation piece. You're going to get all kinds of cool questions about that, and I'm excited for you. Oh man, that makes me happy. That's awesome. Yeah. I can send a picture on Discord later. I'll share it on Monday then. Or if you put it on later today when I'm still streaming, we'll share it. Yeah. He's getting a towel. Guess how old he's turning? Towel. Can't be that old. He's throwing in the towel, Lenina. Danny needs more nerd-doms. Evidently, don't forget your towel. I often pack a towel when I travel. Oh. Hitchhiker's Guide to the Galaxy. There you go. Okay. Okay. I read that a long, long time ago. Goodness, that must have been like 10 years ago now at this point. If not longer. Probably longer. But yeah. Okay. Not at the forefront of my mind. But that's cool. That's cool. That'll be neat. That'll be really neat. Anyway, let's continue. On the answer to life, the universe, and everything. Yeah, they asked ChatGPT that, right? Yeah. I remember.
To these changes over the long course of Earth's history through a process that still continues today, evolution. This powerful force is, in the simplest terms, just change over time.
I'm not really into astronomy at all, honestly. No, don't know much about it.
And for generating the diversity that we see in the fossil record as well as in modern ecosystems. It's the very foundation of our understanding of biology, and it continues to help us make sense of the world around us. As a scientific concept, evolution was revolutionary when it was first introduced. Charles Darwin and Alfred Russel Wallace were the first to put all of the pieces together into a...
Tanareem says astronomy is great too, to be honest. Of course it is, yeah. Shoot, there are so many different sciences, different branches of science that I don't know hardly anything about because I'm a specialist in paleontology. But I hope it goes without saying that different branches of science have all got different ways of learning about the world around us and the universe that it's contained within, and that's all super, super cool stuff. Though I hope that goes without saying. I hope nobody watching thinks like, oh, Danny's a paleontologist, so like he doesn't appreciate astronomy or psychology or chemistry or whatever else, you know? Like, we're all scientists. We're all in this together trying to learn about this incredible natural world around us. Yeah. Yeah.
A unified explanation that would radically alter our understanding of life on the planet. But our understanding of evolutionary theory didn't stop there. We've learned a lot, and we are still learning.
Oh, yeah.
In the last 160 years, we've learned what Darwin and...
Oh, is she at the Smithsonian here? Yeah, this is the National Museum of Natural History. There's a Hatcher Triceratops specimen, and there's the Wonkel Rex chowing down on that frill. Good stuff.
Wallace didn't know. And we figured out a lot about how evolution actually works, like how it can produce the incredible array of animals you see here, and how we know they're all related.
When the Smithsonian opened its first exhibit of fossil animals in the early 1900s, it was called the Hall of Extinct Monsters. Today, Callie and I are in a space that's completely renovated and reimagined. The David H. Koch Hall of Fossils Deep Time, also known as the Deep Time Hall. And it depicts more vividly than ever the staggering variety of animal forms that have arisen and disappeared over time. A monument to the fact that, as Darwin himself put it, endless forms, most beautiful and most wonderful, have been and are being evolved.
Remember when I said that the word evolution only appears once in that entire book on the origin of species? It's not really the word evolution, it's the word evolved, and it's the last word in the book, right there. Yeah. Little Pink Pony says, I haven't been to the Smithsonian since I was a kid. I need to go again. It's only a few hours away. Awesome. I've not been since I was a kid, but I live in California. It's a long way away. But I'm hoping at some point in the next year, I'll get a chance to visit. And I'm going to have to call up some of my friends and colleagues who work there. Give Matt Carano a ring and be like, hey, I want to look at some of your stegosaur material. Yeah. Good stuff. Yeah. Here, let's continue.
Charles Darwin and Alfred Russel Wallace were both British naturalists whose thinking about the natural world was deeply shaped by long voyages of exploration. Darwin famously traveled to South America and the Galapagos Islands, and Wallace went to South America and Southeast Asia. And together they observed an incredible diversity of life. They saw firsthand how very similar organisms seemed to be slightly modified in ways that made them ideally suited to their environments.
For Darwin, he saw this in the different shapes in the beaks of finches on the different islands of the Galapagos archipelago. For Wallace, it was the difference between monkeys living on different riverbanks in the Amazon. And they both realized that the patterns they observed meant that these species all probably arose from the same place, a common ancestor. The bodies of these animals, they realized, had been shaped over time by the conditions in their environments, resulting in the different forms they found on different islands and riverbanks.
But in addition to being well-traveled, Darwin and Wallace were also well-read. And
so this is the cool thing, is that old Chucky D and Charlie Wall, they or Charlie Wall, Alfred Wall, Charles Darwin and Alfred Russel Wallace, both these guys basically discovered natural selection and common descent. They discovered it at like the same time on opposite sides of the globe. And it's just really cool to think that, like, I don't know. Sometimes you get people who are like really offended by the idea of evolution, and they're like, "Oh, you know, this is Darwin's theory, and it's Darwinism. We don't like Darwin." It's like, well, shoot, it almost wasn't Darwin's theory. Like, I don't know, if the HMS Beagle had sunk, Alfred Russel Wallace would have published this idea alone, and probably some other scientists would have joined in there too. The thing is, if an idea in nature is true, if there's a real phenomenon, if something, like, if there's a way that the world actually works, somebody's going to figure it out. Doesn't really matter who. So, doesn't matter that it was Darwin. You know, it's not Darwin's idea. It's just, that's the way that the world works. And old Chucky D was, he gets a lot of attention for being one of the first people to ever publish on it. But if it hadn't been for him, it would have been someone else. Because this is the way that the world works. This is actually how living things change over time. It's not like it's some, you know, philosophical idea or something like that, or a particular trend in art history or something where it's like dependent on who the author or the artist or the, you know, the progenitor of this idea is. Like, it's science. It is what it is, regardless of who discovers it. And if Darwin hadn't, somebody else would have. And somebody else kind of did. I mean, Alfred Russel Wallace, independently, discovered these same ideas, and then they jointly published some of these papers. I think this is, they're going to get into that here.
By the conditions in their environments, resulting in the different forms they found on different islands and riverbanks.
But in addition to being
There
well-traveled,
you go, Steely Dan, yeah.
Darwin and Wallace were also well-read, and their ideas were deeply influenced by other earlier thinkers
Wolf.
in
There you go,
history,
HD. Yeah.
geology, and even economics.
Chuck and Alfie, there you go.
Georges Cuvier,
Dr. Irrefutable, I like that.
Jean-Baptiste Lamarck, and Thomas Malthus helped.
Yeah, three of these people had tremendous influences upon the history of paleontology. Georges Cuvier is often called the father of paleontology. He kind of discovered the idea of extinction. Charles Lyell, often called the father of geology. And Jean-Baptiste de Lamarck had early ideas about evolution. He was wrong about the mechanism, but he posed some really interesting questions that kind of laid the groundwork for later people like old Chucky D.
Helped establish the ideas that were critical to evolutionary thinking. Namely, that the Earth was very, very old, that species seemed to change and go extinct over time, and that individuals competed over limited resources. Darwin and Wallace used these insights, along with their own observations, to both arrive at the same mechanism by which species evolve: natural selection. In a paper read to a meeting of scientists in London in 1858,
and there you go, Gamers Tavern Show. That's a good point.
Their theory of natural selection based on a series of principles.
The first key idea was that in a population of living things, natural variations will occur. And as a result of those changes, some members of the population will survive and reproduce more than others. Then they thought that those that survived and reproduced will pass on their traits to their offspring. And this meant that traits that give an individual an advantage in a certain environment will get passed on more often. As a result, more members of the population will have that trait. Therefore, gradually and over time, this will result in certain traits showing up more or less often in a population. Today, when this series of events happens within a species, we call it microevolution. It's how a single species responds to changes in the environment.
And actually, I don't really hear that phrase all that often. Maybe this is because I'm not running in the circles where they use this kind of terminology, but microevolution and macroevolution are not two separate things. Like, they're just different scales that you look at the process of evolution on. It's the same processes that that underpin both of these, you know? Yeah. And Dr. Irrefutable says, I'm not sure I've ever seen a video that included Alfred Wallace so much. Honestly, I don't remember hearing about him. Yeah, I mean, that's the thing, is that he often doesn't get as much of the attention because, well, he was younger than Darwin. He was working class, whereas Darwin was like upper class. He didn't have as much formal education as old Chucky D did. He didn't have the same connections in the scientific world that Darwin did either. And yeah, but maybe we'll talk about Alfred Russel Wallace in a little bit also, because there's a cool video about him that I could show you. We also need to figure out when he was born so that I can see if I should do an Alfred Russel Wallace birthday stream. Alfred Russel Wallace, born January 8th. All right, let me put that on my calendar here. Yeah. January 8th. Nice. We'll be talking about him in January. Extensively. Good stuff. Yeah, and he died November 7th. That's 4 days from now. Cool. Yeah. And Gamers Tavern Show says microevolution and macroevolution are terms I only ever hear from creationists, saying the former happens but the latter doesn't, which is really funny because it's the same thing. You know? It's like saying, well, you know, I can walk to the other side of my bedroom, but I can't walk to the refrigerator in the kitchen. It's like, it's both of them are walking. I don't know. So yeah. Yeah. And yeah, Henny says creationists seem to treat Darwin's book like a Bible. Funny how that works, huh? But that's not how science works. Evolution has been refined since then, refined tremendously. And Darwin was wrong about a lot of stuff. He speculated on how whales may have evolved. He's like, well, maybe there was a creature like a bear, and it was swimming around in a river and, you know, gathering up insects in its mouth. And like, that was how he imagined whales may have evolved. He was speculating there, and he was wildly wrong about that. He was going way off on a limb, and he said this is very speculative, but like, oh man, that was super wrong. And he was wrong about a few other things too, but it's funny, by and large, Darwin tended to be right about most of the things that he wrote about, because he was a really cautious guy. I'm sure he had all kinds of other ideas that just he never published on because he didn't have the evidence to support them, you know? Very, very cautious, careful, dedicated scientist. Yeah. But he did see that whales once lived on land, and that's still a huge leap. I guess, Javasaurus, yeah. Darwin realized that whales were mammals, and mammals primarily live on land, and so he did make that inference that, like, shoot, this means that whales must have evolved from a land-living ancestor, and he was right about that. Yeah. Anyway, yeah. Rad Acid says creationists often think of that science works like biblical canon, and use the fact that science changes as proof of it not being true. I mean, yeah, that's honestly one of the biggest misconceptions that people like creationists have about science, you know? They think the fact that in science we change our views to fit the evidence, especially when new evidence arises, they think that's a weakness rather than a strength. You know, like it's a bad thing to learn new stuff. So it's kind of like a fundamental difference in philosophy, and that can be really, really hard for people to unlearn. People who may have like grown up in a creationist context. So yeah. Anyway, let's continue with our video here.
On a broader scale, we call it macroevolution. This is how these changes accumulate over long periods of time to produce entirely new body plans, new species, and the grander patterns of the diversity in the tree of life.
And one of the most incredible things about the development of the theory of evolution by natural selection was that Darwin and Wallace didn't have a good explanation for how traits were passed from parent to offspring.
Yeah, this was really like one of the biggest challenges to evolution at the time. Is like they didn't really have a mechanism. And the same way that Alfred Wegener didn't really have a clear idea of a mechanism for how the continents could have moved. And that was a big problem for his idea. When Chucky D and Alfie Wallace were publishing their ideas, they didn't know about genetics. They didn't know about DNA. These things had not been discovered yet. This would only happen in the future. And so this was like a major, major time when all of that could have been turned over. Like, this was a major test for the idea of, as they called it at the time, descent with modification. Or what we today would call evolution.
Does it?
Let me show you a clip there. Here, we were gonna watch this the other day and we got distracted.
Of the individual organism's characteristics. During reproduction, chromosomes from each parent replicate.
So we talked about this earlier.
Shuffle their parts to produce new chromosomes.
Yep.
Then each parent passes chromosomes to offspring. But the process is imperfect. Along the way, DNA is subject to random mutations or mistakes.
We talked about this.
Giving each offspring its own unique blueprint.
Sometimes this produces characteristics in offspring that are benign. Other times it produces harmful characteristics, like a misshapen wing. But occasionally, the process gives rise to a beneficial trait. For example, a butterfly whose color...
So I kind of disagree with this example here. Like, this is not really an ideal illustration because maybe this is something that can change with just one gene, you know, like one allele changes and then suddenly you've got blue coloration like that. But to me, this almost seems like hopeful monsterism. I don't know. Yeah. And DNA is short for deoxyribonucleic acid, Tanareem. Yeah. But I don't know. I don't know enough about butterflies and their, you know, heredity and genetics in order to say that, like, oh, this is too dramatic a change for one gene or something. Maybe it's not.
Coloration mimics another species that tastes bad to birds.
Yeah.
About 100 years.
And there you go, Hennies. Yeah. The environment can change and make a useless mutation very useful. Oh, yeah.
Appearing in a population. Genetics revealed the biological mechanism that gives rise to those traits in the first place.
Yep.
And therefore, you could say that when modern genetics came into being, everything in Darwin's theory was at risk. Could have been overturned if it turned out that genetics contradicted the essential elements of evolutionary theory. But it didn't contradict them. It confirmed them in great detail.
Which is really incredible that, like, you know, Alfie Wallace and Chucky D, they didn't know anything about genetics. DNA would have blown their minds. They had no idea that this is how things worked. And yet, their ideas about natural selection fit with that perfectly. And there's no way they could have known that, you know? It's just so cool how when you're getting close to the way that things actually are in the natural world, when you're studying these things through science and, like, you get pretty close to explaining something, sometimes everything just kind of fits into place if your explanation is a good one. And that's exactly what happened here.
And as Miller would testify, a genetics paper published less than a year before the trial had confirmed what has long been the most inflammatory part of Darwin's theory, the common ancestry of humans and apes. That paper explored a curious discrepancy in our chromosomes. The cells of all great apes,
Puzzle of science.
like
There you go.
chimpanzees,
Fox
gorillas,
Mulder, yeah.
and orangutans, contain 24 pairs of chromosomes. If humans share a common ancestor with apes, you'd expect us to have the same number.
But we don't.
But surprisingly, human cells contain only 23 pairs.
Yep.
The question.
Yeah, which is close, but no banana, you know? By the way, 23, like I said the other day before we got interrupted with a raid, I think it was. That was a good interruption. But that 23, that's where the, 23andMe, the genetics testing company, that's where they got their name. 23 pairs of chromosomes in the human genome.
If evolution is right about this common ancestry idea, where'd the chromosome go?
Yeah.
Well,
why do we have 23 and not 24?
Evolution makes a testable prediction. And that is that somewhere in the human genome, we ought to be able to find a piece of Scotch tape holding two chromosomes together.
So instead of 24, two of those got stuck together, so now it's just 23. That's the idea.
That our 24 pairs, two of them were pasted together.
There you go.
To form just 23. And if we can't find that, then the hypothesis of common ancestry is wrong and evolution is mistaken. Next slide.
To solve this riddle for the court, Miller would show how scientists discovered traces of our evolutionary past buried in the very structure of a chromosome carried by...
And Jack's facts. Holy cow.
Wow.
Welcome to Paleontologizing, Jack's facts.
Want to know what it's like.
How are you doing? How was your stream? What kinds of animals did you talk about today, Jack's facts? I want to hear all about it. If you are not following Jack's facts yet, everybody, if you like zoology, if you like animals, go check out Jack's facts. Yeah, Good stuff. So you already know about this, Jax Facts. I was going to rewind a little bit, but you and your audience are probably well familiar with, you know, why humans have 23 pairs of chromosomes and the other great apes only have 24. But we're talking about evolution and how it works and how we're able to figure this out as scientists. So that's what we're in the middle of right now. So welcome, Jax Facts. Yeah. And living animals. Yes, Jax Facts works on living animals. Yes. So where did the chromosome go? Here, let's rewind just a little bit. Here we go. I apologize about the repetition, but
we ought to be able to find a piece of Scotch tape holding two...
This is it.
Oh.
This is the horizon, which marks the extinction of the dinosaurs.
Something about this video clip
Below this level, and out in
means
here,
we just
there are
get rated.
dinosaur fossils.
This is great.
Above this level, on these rocks, there are no dinosaur fossils.
Seaborn
I'm
Show.
Standing on the level that marks the extinction of the dinosaurs.
Welcome to Paleontologizing. How was your stream?
Traders have stumbled below that level.
I hope it was really good. Welcome to Paleontologizing, Seaborn Show. I hope you had a good time. It's good to have you here. Yeah, welcome back to Paleontologizing. Yeah, we are talking today about evolution. We've gone on a few tangents here, which is great. That's what live broadcasts are all about when you're doing science outreach, you know? Answering questions that people have in real time, that's what I'm here to do. So we've been talking about human evolution for a minute here. And here we go. Yeah. Talking about DNA, how the discovery of DNA could have posed a huge challenge to evolution. Jody Fish, thank you for those 5 gift subs. Thank you. Look, just 55 more and we'll make our sub goal for the day. Not for the day, for the week. Yeah. Jody Fish, thank you for those 5 gift subs. I appreciate that very much. Thank you for supporting me and supporting science outreach here on Twitch. It's important stuff, Jody Fish. Thank you for your support. So yeah. So we're talking about heredity and DNA and how, when old Chucky D, Charles Darwin, published his ideas on evolution, he had no idea about things like DNA and genetics. No concept of this whatsoever. And so when DNA was discovered, this would have been like a huge test. And shoot, it passed. Take a look.
And therefore you could say that when modern genetics came into being, everything in Darwin's theory was at risk. Could have been overturned if it turned out that genetics contradicted the essential elements of evolutionary theory.
Yep.
But it didn't contradict them. It confirmed them in great detail.
And as Miller would testify, a genetics paper published less than a year
This is so
before
cool.
the trial
Check this out.
had confirmed what has long been the most inflammatory part of Darwin's theory, the common ancestry of humans and apes.
Inflammatory flames, get it?
That paper explored a curious discrepancy in our chromosomes.
Yeah.
The cells of all great apes, like chimpanzees, gorillas, and orangutans, contain 24 pairs of chromosomes.
Not us, though.
Humans share a common ancestor with apes, you'd expect us to have the same number.
But we don't,
But
which is
surprisingly,
weird.
Human cells contain only 23 pairs.
Yeah.
The question is, if evolution is right about this common ancestry idea, where'd the chromosome go? Well, evolution makes a testable prediction. And that is that somewhere in the human genome, we ought to be able to find a piece of Scotch tape holding 2 chromosomes together, so that our 24 pairs, 2 of them were pasted together to form just 23. And if we can't find that, then the hypothesis of common ancestry is wrong and evolution is mistaken. Next slide.
To solve this riddle for the court, Miller would show how scientists discovered traces of our evolutionary past buried in the very structure of a chromosome carried by all humans.
Which is pretty cool.
Typically,
Check this out. This is really neat.
On the ends of every chromosome, you should find special genetic markers
called telomeres.
Sequences of DNA called telomeres. And in their middles, you should find different genetic markers called centromeres. But if a mutation occurred in the past, causing 2 pairs of chromosomes to fuse, we should find evidence in those genetic markers. Telomeres not only at the ends of the new chromosome, but also at their middles.
And holy cow, Descartes Games. Welcome, welcome to Paleontologizing. Holy moly. Is it good to have you here? Hello, hello, and welcome to Paleontologizing. Holy cow. What a wonderful raid. I really appreciate that. So many names coming in here. So many follows. Fantastic. Holy cow. Well, shoot. I'm going to turn off my alert box real quick here. And welcome you to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. And I'm here on Twitch trying to do some good old-fashioned science outreach. So we're talking all about... Well, we were talking about new discoveries in dinosaur paleontology this week. And now we're talking about evolution because we had some questions from some viewers. So yeah, we'll get back into that in a few minutes, but Descartes Games, how was your stream? I hope it was wonderful. Welcome to Paleontologizing. Some of you are probably wondering how a paleontologist came to be here on Twitch in the first place, what this channel is all about, and so without further ado, I'm going to introduce you to somebody we like to call Previously Recorded Danny. So without further ado, let's bring him on, and he'll clear that up for you. So, Previously Recorded Danny, go ahead and take it away.
Thanks, present day Danny. You know, people ask me all the time, Danny, how did you first get interested in paleontology? And I've always been interested in fossils from the earliest time I can remember, particularly dinosaurs. My parents like to say that I decided I wanted to become a paleontologist pretty much the moment I realized I couldn't grow up to be a dinosaur. And believe me, I tried.
I was born and raised in the San Francisco Bay Area, which is a lovely place to grow up. Except that we haven't got any dinosaur fossils here. So right after high school, I packed up and moved to Montana, one of the best places in the world to find dinosaurs. Just a couple days after I arrived in Montana, I started working at the lab at Museum of the Rockies, and the paleontology program founded by Jack Horner. Jack's done a lot of amazing things in his career, but you may know him as the scientific advisor on the movie Jurassic Park.
You consulted on that movie.
I did consult on all those movies.
And they said the guy, Alan Grant, was you.
Yes. Yeah, well, fortunately, he didn't get eaten.
But we wanted a credible resource that could back up several theories that we were sort of expounding. And one was that dinosaurs eventually evolved into birds.
And even the word raptor means bird of prey.
And that's something that Jack Horner believes in and could defend if necessary. And Jack Horner became our credibility.
It was in this program that Jack built that I learned how to be a dinosaur paleontologist and how to think outside the box. I've done work at a number of other museums around the American West, helping to prep fossils, design exhibits, and educate visitors. I did a fair bit of eclectic fieldwork in various places, identifying and collecting early Cretaceous dinosaur tracks on the Idaho border, Sphenodontian fossils in the gravelly range of the Rocky Mountains, Cenozoic fishes in western Nevada, but most of my work out in the field was with Dr. Denver Fowler, who is now curator of the Badlands Dinosaur Museum. In all, I've worked probably a few hundred sites throughout the late Cretaceous of Montana, in the Hell Creek and Judith River formations, digging up dinosaurs. Lots and lots and lots of dinosaurs. And from time to time, that work has even garnered some media attention.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
We found its head, and we found parts of its armor and plates, and so it should be a new species.
And much like my fieldwork, my research focuses on dinosaurs.
I'm particularly interested in their behavioral functional morphology. All these bizarre anatomical features that certain dinosaurs had, I want to know what they used them for. Right now, I'm working on a study on spinosaurs.
All right, but don't ask me too much about that because it's still a project in the works, and I can't give away too much just yet till it's published.
But anyway, a couple years ago I realized that things were definitely headed downhill in Montana. So I packed up and headed back to the West Coast.
And I've become kind of fed up with all the bullshit in academia, so I found myself another job.
I am now a teacher in early childhood education. And let me tell you, it's been a natural fit since day one. Now, given that I get to design the curriculum, my students now know more about biology, classification, and the history of life on Earth than most adults do. I've been helping raise a new generation of young scientists. Then, coronavirus hit. In mid-March, when all the schools shut down in San Francisco, I started holding classes over Zoom, and we picked up right where we left off. 1, 2, 3. I love digging in the dirt with just a pick and brush. Finding fossils is my aim, and so I'm never in a rush, because the treasures that I see are rare and ancient things, like velociraptors' jumps or Archaeopteryx's wings, and all the kids who wanna see them lining up at our museum. I am a paleontologist. That's who I am, that's who I am, that's who I am. I am a paleontologist. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. I realized that I really enjoy teaching remotely. So back in May, I decided to try streaming on Twitch. And here we are.
This is my passion, and now I get to share it with you. And what could be cooler than that?
I believe that scientists ought to be public servants. Ultimately, it's our job not just to make scientific discoveries, but to teach the public about them. That's exactly what I want to do here. Now, because of COVID-19, this will be my first summer in almost 10 years with no fieldwork. I'm trying to look on the bright side, though. It's not all bad. At least I have more time for outreach. And I've got plenty of cool stuff to work on. And if you could throw some support my way by subscribing, I'd be incredibly grateful.
So anyway, if you are new here, you should be pretty well clued in by now. And I'm glad you're here. I hope you're having a good time. Anyway, let's see what present-day Danny has cooked up for us. All right, present-day Danny, back to you.
Well, thank you very much, previously recorded Danny. And of course, thank you even more to our friend Descartes Games for that raid. I really appreciate that. And welcome, everybody. That video is a little old at this point. I really need to update that, but I've been so busy with, fieldwork live streams this summer. We were digging up dinosaurs live on stream. At least 3 new species this summer in Wyoming and Utah.
Science. What science haven't done for us? TV off.
And I guess I can turn the alerts back on, right? Let's see. Where did those go? There we are. Good. Yeah. I don't know. I've had a really busy past 2 weeks too, but finally I might have a chance to maybe put together some new welcome videos at some point. But anyway, if any of you happen to have any questions about dinosaurs in particular, since dinosaurs are what I work on, or if you have questions about natural history, extinction, evolution, the fossil record, the philosophy of science itself, any of that stuff, don't be shy with your questions. I'm here to be your friendly neighborhood paleontologist. So ask away. This is my way of doing science outreach. So yeah. Sunbright, how are you doing? Welcome. Melissa Burbs, what a great name. Yeah. Anyway, and mosasaur subscribed for 3 months at tier 1. Holy cow. Mosasaur?
If they're removed, America loses them.
That is incredible. We are going to talk about that brand new mosasaur in just a few minutes here.
Let's protect our fossils, because if they're removed...
And Serenity Moonlight,
forever.
Thank you for subscribing with Prime there. I really appreciate that. Thank you, thank you. Holy cow. Good stuff. Good stuff. Yeah. And we got a hype train going. Beautiful. Thank you for the 100 bits there, Mangort. By the way, if we get to our sub goal for this week, this is our last day to try and get to our sub goal. And Annie, are you okay? Thank you for the follow too. Welcome, welcome. If we get to that sub goal today, by the end of the stream, I'll play some ukulele songs about science and about dinosaurs. So, let's see if we can get there. Yeah. Now's a good time to try, I guess. We've got this hype train going. Yeah. But we had someone in chat. It was Sammy someone who was asking about that coelacanth model. That's my papercraft coelacanth model, which I have over here. Coelacanth, one of my favorite extant non-tetrapod fishes. But earlier this autumn, I 3D printed a nearly life-size coelacanth. I guess it would be life-size for a small coelacanth. It's not painted yet, but I have it over here. Let me show you. Check that out. Latimeria chalumnae. The West Indian coelacanth. West Indian? East African coelacanth? Comoran coelacanth? Whatever you want to call it. But, pretty cool. I cannot wait to get this thing painted. Nageo Jim, thank you for the 600 bits. Thank you very, very much. That is good stuff. I appreciate that, Geo Jim. And it's not often we see that alert. But yeah. This is such an incredible creature. If you don't know the story of the coelacanth, holy cow, you're in for a surprise. So, coelacanths, this group of fishes had been well known from the fossil record for 100 years. They're kind of a quintessential extinct fish. And they disappear in the fossil record at the end of the age of dinosaurs. They went extinct at the same time as the non-bird dinosaurs did. When the asteroid hit the Earth 66 million years ago. So yeah, well-known, extinct fossil fish. Then in 1938, a living one was discovered. A fishing trawler off the east coast of Africa, east coast of South Africa, near the Chalumna River, brought in a coelacanth, and holy cow, it was a big deal. It was really, really cool. Here, I'll show you a really, really neat video. It's, that one's a little long. Let's just take a look at this one. I'll tell you the full story of the coelacanth on December 23rd, on the anniversary of that discovery. It was December 23rd, 1938, that Marjorie Courtney Latimer found it. In fact, maybe this is not the right... place to start. Coelacanth. Documentary trailer. Let's try this at the beginning. Yeah. All right.
In the waters off the east coast of South Africa, 300 feet below the surface.
And yes, Tomas, that's the mosasaur I'm going to talk about. Yeah.
A creature that existed before the time of the dinosaurs.
We haven't talked about it yet, but we will after this.
350, 400 million years old.
Some call it the ghost fish, king of the sea. Others, monster of the deep.
On a moonless but fairly bright night, You can actually see those eyes glowing.
What an incredible animal.
Half a century,
Yeah.
the search has persisted.
There have been divers who've died trying to find these fish.
Yeah.
Those who come in contact with it are changed forever.
You get this kind of science fiction chill in the back of your neck and going down your spine.
A creature that offers tantalizing clues to the evolution of all life on Earth, including us.
Tetrapod life. Yeah.
I did see one alive, and I never got over that.
A creature thought to have been extinct for over 50 million years.
Yep.
It's alive! Ancient creature of the deep. Up next on Nova.
Yeah. Good stuff. Here, let's go to the beginning. Yeah.
Team of divers.
They're gonna try and find it. And holy cow, there it is.
Its ancestors date back 400 million years to a time when all Earth's creatures lived underwater, and the great transition to living on land was about to begin. Was the coelacanth, with its fleshy leg-like fins, the missing link in evolution from fish to land?
And they're always so slow until they're not. They can swim really fast when they want to, Sammy Gull.
To science only through ancient fossils that displayed these curious limb-like fins.
And Heaven's Cloud, thanks for dropping in there with that follow. I appreciate it. Welcome to Paleontologizing.
But one fateful day in 1938,
there we go.
Everything changed.
Here's the woman who made the discovery.
Welcome to Six Lakes Street.
Marjorie Courtney Latimer was then the 31-year-old curator of a small natural history museum in East London, South Africa.
Come, welcome in.
She remembers well how her life was turned upside down by the mysterious coelacanth.
Yeah.
Nobody.
I love that her home is just full of coelacanth pictures.
And the
That
trauma
makes
that
me
I went through. I
happy.
went through absolute trauma saving that fish.
But in the serious game of paleontology, much larger mysteries still remain.
And Sammy Gull, thank you for that follow. I appreciate that. I'm glad that a fellow coelacanth lover here. Welcome.
Because nobody wanted to know. I would say even my family in the end began to think I was cuckoo. So there was a cuckoo.
Yeah.
On December 22nd, 1938, a fishing trawler steamed into the East
I heard it was the 23rd. I'm going to have to figure that out because that's the day we're going to have our special stream. On the 22nd or the 23rd.
Sea life dredged up after a freak storm. But these fish were not all meant for market.
It was a pile of sponges and starfish and rat-tailed fish, and you name it, they were there.
When putting together new exhibits at the museum, Marjorie often obtained samples from local fishermen.
And from underneath this crowd, there was this one fin sticking out.
Yep.
This blue fin. And I thought, what on earth could this be? Then I moved all the fish. There was this beautiful, beautiful fish.
And they really do have extraordinary fins.
All over the
Really beautiful.
just solid, just on 5 foot long, rough scales, very big eyes, very big blue eyes. These peculiar limb-like fins, something I'd never seen in a fish in my life.
She knew it was something special.
Had been an avid collector since childhood. She knew instinctively that this was an important find.
But how important maybe she didn't quite realize? She knew it was important and she knew she had to save this fish for science. But man, did she not... Little did she dream how very important it would be. The story of the coelacanth is a really, really interesting one, and I'm really excited to do a whole special coelacanth extravaganza about it in December. Which day is that going to be, though? Let's see. Latimeria chilimene, the West Indian coelacanth. There we go. Habitat and behavior. Discovery. Yeah, see, December 23rd. That's what I always heard. So yeah, it'll be on December 23rd that we have our special coelacanth stream. Merry Fishmas. It's gonna be great. Anyway, good stuff. Paleontologist VA says, I have been working on a coelacanth from the Triassic. Very cool. Yeah, so these go back to the Triassic and earlier. And just the other day, let's see, switch accounts here. There we go. It's probably this one. Nope, not that one. There we go. Yeah. The most dangerous petrified forest fish from Petrified Forest National Park. An immense coelacanth stalks sizable prey in upper Chinle Formation waters. A single species of coelacanth has been named for the Chinle Formation. It's called Chinlea. I know of this one. I've seen its fossils in the museum collections at Berkeley. And that is Doug Henderson's illustration of it. The back of it, just kind of slowly making its way through this this waterway in the Chinle Formation, late Triassic of Arizona. This is around the time that some of the first dinosaurs in North America were running around doing their thing. First dinosaurs we have from North America so far. Yeah. And did Spinosaurus eat coelacanths? They did, Great Sag, yeah. Yeah. I work on Spinosaurids, as you saw in the cold open video, and you'll see lots and lots of illustrations of Spinosaurids going after Cretaceous coelacanths. Like this right here. Yeah. It's almost a trope in these illustrations. Yeah. Because, yeah, there were some big coelacanths back then. Critters like Mawsonia. They got pretty enormous. Like, that big. Enormous animals. Yeah. Pretty extraordinary. Yeah. And, so, je suis une personne sans nom? You're a person without a name? Well, I'm glad you're here. How can you determine what type of fish a dinosaur ate? Well, in this case, we speculate that Spinosaurus probably ate these guys, because we know that Spinosaurus was a fish-eating dinosaur. And this is one of the biggest fishes in that environment, and would have made a pretty decent meal. But the way to actually determine that a certain species of dinosaur ate a certain other species is by, you might find evidence of that actually in gut contents. So you might find preserved within the ribs of a dinosaur the remains of its last meal. That's one way of doing it. You can also look at things like bite marks. It's honestly the much more common way of doing that. Like looking for like particularly shaped marks on the bones of the prey animal. And if you can match those up to the teeth of the predator, then there you go. Yeah. In many ways, being a paleontologist is a lot like being a detective. You know, it's a similar kind of way of looking at problems and trying to solve mysteries. You know, looking for evidence that's been left in the rock record for us. So yeah. And Great Sag says, was there saltwater and freshwater back then? Which did the coelacanth or Spinosaurus swim in? So despite what you see right here, with this Spinosaurus swimming under the water, they almost certainly did not do this. Spinosaurus was not an underwater aquatic dinosaur like this. We've got multiple lines of evidence that show that they weren't like this. For one thing, they were way too buoyant. Like, they would not be able to dive under the water like this. Yeah. But these are animals that are probably living in freshwater and brackish water environments. So they're living inland in freshwater rivers and lakes, and then kind of in brackish environments where, you know, that fresh water goes out to sea and it starts to get salty. They're living in delta environments. They're living near the coast, areas like that. This is Spinosaurids in general, not just Spinosaurus, but also Baryonyx, Suchomimus, Irritator, Oxalia, etc. So yeah. And San Miguel wants to know, can fossilized feces help with determining what something ate? 1,000,000% yes. That's one of the best ways of determining, like, who's eating what in the fossil record. But then you've got to... It becomes difficult to actually identify who may have been leaving those coprolites. So as Professor Karen Chin would say, you got to figure out who the poopatrator was. Here's a little video about that.
Like phosphorus or calcium from the bones and tissues of a carnivorous dinosaur's prey.
But if you take dung from herbivorous animals, in order to preserve those, you actually need an external source of a mineral. Paradoxically, that comes from the bacteria that are feeding on fossil dung.
So yeah, fossil dung or coprolites are really, really important. And paleontologists like Karen Chin study them. Play.
Techniques to try and determine if it is fossil feces or just a pretty rock.
Once she's fairly certain she's got the real deal, Dr. Chin can begin to investigate its origins.
Yeah.
You don't know who the poopatrator was, right?
That's really important to understand. If you're trying to use fossil dung, coprolites, as evidence of, like, you know, what a certain creature was eating, you got to make sure the poop comes from that animal. You gotta figure out who the poopatrator is. Yeah. And let's see. Chaco Keki says, does the anatomy of a dinosaur also help determine its diet? Yes. That's usually the evidence that we have as we look at the teeth, we look at the jaws, we look at the overall body plan, and we figure out, is this a fast-running animal? Is it a slow animal? Is this a browser? Is it a grazer? Is it a predator? Its overall body shape and its teeth can all give us clues about that, but if you want hard evidence, if you want to actually determine not just what does it look like they're capable of eating, but what did they actually eat, you look for other forms of evidence. You could look at tooth wear. You look at bite marks on other animals' bones in the case of predators. Or you look at coprolites, fossil dung.
First, see if I can see anything recognizable on the surface, such as dietary residues or burrows from organism that burrowed in after it was deposited. I may make a thin section of it. I cut out a little piece and then I grind that down so you can see through it. Again, it's almost like you're in the field. You're like searching around the slide. Oh, what is that? Clues that say these are plant cells, these are animal cells, this is a piece of bone, it's a piece of shell.
Dr. Chin and her colleagues can then start to get into the nitty-gritty.
I might do a chemical analysis of it to see what kind of mineralogy it had. You can look at organic geochemical analyses or isotopic analyses. This is a kind of a new field in studying coprolites.
And with new techniques can come new insights.
One of my colleagues, James Super, analyzed some coprolites from the Arctic. Inside, he found compounds that give us clues about how warm it was 78 million years ago above the Arctic Circle.
Pretty cool. From fossil poop, you can determine what the climate was That's pretty extraordinary, right?
But of all the coprolites Dr. Chin has examined, none have provided more insights than those from western Montana's Two Medicine Formation.
Oh yeah, from Egg Mountain. I've been there many times. And Aerospace News, the stream is going well. And I'm doing great, or vice versa. Things are good. Thank you, Aerospace News, and welcome back.
I have spent many years studying these coprolites, and one thing that they revealed early on was the presence of very distinctive burrows that indicate the activity of dung beetles.
As well as the occasional snail shell. More important,
they were filled with tiny pieces of conifer wood.
Dr. Chin mulled over those wood fibers until she realized that the dinosaur that ate them wasn't just munching on a pine tree.
Wood had actually been rotted before the dinosaurs ingested it.
So why would you have a dinosaur ingesting rotting wood? Does anybody have any ideas? Especially new folks here, any ideas why a plant-eating dinosaur would be eating rotting wood? Digesting nutrients? Why would you? There you go, HD. Yeah. Yeah. Well, let's see.
We don't have modern mega herbivores like elephants making a practice of feeding on rotting wood, so that was a real surprise.
Strange.
But Dr.
Why are they
Chin
doing
had
that?
a hunch that maybe these duck-billed dinosaurs had been snacking on something else entirely.
Invertebrates frequent rotting wood, so
Yep.
if those dinosaurs needed a good source of protein, they go to a rotten log, and that's a great way to find proteinaceous invertebrates.
So that's a duck-billed dinosaur doing that right there. A duck-billed dinosaur, like, in this case, it's probably good old Maiasaura in the Two Medicine Formation. The good mother lizard was also probably the bug-eating lizard. Not a lizard, but it's a dinosaur, you know. Yeah. Interesting to think about. That a dinosaur that is ostensibly an herbivore would be maybe, before laying her eggs, would be eating a bunch of bugs in order to get that extra protein, you know? To give her offspring a better chance at survival. You know, having more well-developed embryos through more protein that the mother ingested might give them a better shot at survival. Given that Egg Mountain and the Two Medicine Formation, this is like, you know, a nesting ground for the Maiasaurs. Maybe that's what they were doing there. Which I think is really cool to think about.
And that's a great way to find proteinaceous invertebrates.
Her hypothesis was backed up when colleagues at the Denver Museum of Natural History and Science made their own fecal find.
They found coprolites in the Kaparowitz Formation, which is the same age as a Two Medicine. They also have rotted wood inside. They also have evidence of dung beetles inside. But in addition, they have actually pieces of broken up crustaceans. They were clearly
They're eating crayfish.
So they were ingested.
Put together, these plain lumpy rocks reveal a whole ecosystem.
We have the hadrosaurs, we have conifers, we have white rot fungi, and we have dung beetles and snails, all in this one ecosystem, and we have fossil evidence of how these guys interacted.
Pretty cool.
We can't get that from simple body fossils.
Yep.
Out on
pretty neat stuff. And here's a link to that video if you want to watch the whole thing. It's almost over there. It's a short video. But I always like to share the links when I can. Yeah. So yeah. Good stuff. Great Sag says, imagine going back in time and you see the common snail and dung beetle making you feel at home. I know every time I see snails and dung beetles, I feel at home, Great Sag, yeah. And Je suis une personne sans nom says, weren't the bugs of that period enormous? No, they weren't. I think there's like a common misperception that like, oh, everything was huge back then, and that's not true at all. Most insects during the age of dinosaurs were the same size as they are today, or in many cases smaller. So yeah. You gotta go back long before the dinosaurs. Like 100 million years before the dinosaurs to get to those giant arthropods from terrestrial environments in the Carboniferous. Yeah. This is not an insect, but because millipedes are not insects. But that's Arthropleura, which is from long before the dinosaurs. There's a number of other big invertebrates from the time. And these seem to have gotten big because long before the dinosaurs, oxygen levels were higher. And also, they didn't have a lot of competition from land-living vertebrate creatures. There weren't a lot of vertebrates, backboned animals on land to compete with these guys. And once the backboned animals come up onto land, they mostly kind of keep invertebrates small for the most part by out-competing them. So, yeah. But these are from like 100 million years before the first dinosaurs. A long time before. Yeah. Mayor Space says the perception is that back then is all one time period. Oh yeah, thank you, Mayor Space. Good point. Because it is definitely not. Holy cow. Let me show you something for all our new folks here. This is the International Chronostratigraphic Chart. And thank you, Murph, for those gift subs there. I really appreciate that, Murph. 2 of them. Thank you, Murph. Appreciate you. Yeah. This is the history of life on Earth. On this side, these are millions of years ago. 407.6 million years ago. Back here in the Devonian period. Those giant insects and other arthropods are from the Carboniferous period. So, like, about 330 million years ago. Something like that. Dinosaurs don't show up until at least the Middle Triassic. Or maybe the very beginning of the Upper Triassic. So about 230 million years ago, give or take a few. You know, but what's a few million years between friends? Am I right? Dinosaurs show up here in the Triassic period, and they continue to thrive. They really take over the world during the Jurassic, and they continue to rule the world throughout the Cretaceous until just 66 million years ago, that asteroid hits and kills all the dinosaurs except for birds. Birds are still around today, and birds are living dinosaurs. But anyway, there's something I should point out to the new folks. It's kind of a cliche, but some people haven't heard it yet. There we go. You've probably seen something like this image before, right? There we go. Tyrannosaurus locked in mortal combat with Stegosaurus. T-Rex versus Stegosaurus. It's a battle for the ages, right? Classic. Completely wrong. Completely wrong. So, where is a place where this would actually occur?
Wow, the land of make-believe.
Only in the land of make-believe. These two dinosaurs are separated by about 80 million years. So this is on the Disneyland Railroad, actually. Like, there's a train that goes around Disneyland and, go back to the fantastic age of the dinosaurs at one point between Tomorrowland and Main Street. And at the very end, the finale is T-Rex fighting with Stegosaurus. These two dinosaurs never met. They are separated by about 80 million years of time. T-Rex is closer to Twitch.tv in time than it is to Stegosaurus. There's only 66 million years between T-Rex and Twitch. between T-Rex and Stegosaurus, it's like 80 million years. So yeah, so at Disneyland, it would have made more sense to have the T-Rex menacing, you know, great moments with Mr. Lincoln than have it menacing the Stegosaurus. So yeah, yeah. Anyway, good stuff. The whole point is, geologic time is vast. T-Rex lived here at the very end of the Cretaceous period. Stegosaurus lived here at the end of the Jurassic. So back then is not just one time. There is a tremendous amount of time in Earth history. Like I said, the first dinosaurs evolved about 230 million years ago. And then they go extinct, except for birds, 66 million years ago. But we still have birds today in the present, and we were talking about all that yesterday for Thursday Birds Day. So yeah. Anywho. Yeah. Imagine still having T-Rex alive. Well, that's the thing, is that if it hadn't been for that freak accident where that asteroid hit the Earth, there is no shot that we would still be around, that we would be around today. Humans would have never evolved. Mammals would have probably never gotten big, because mammals evolved at the same time as the dinosaurs, roughly. They both evolved about, 230 million years ago. Back in the Triassic period. Mammals and dinosaurs both originate in the Triassic. But for the entire age of the dinosaurs, mammals... we are mammals. Mammals are... lions and tigers, bears and elephants, rhinoceros, zebras... monkeys and apes and whales and bats and mice, platypus, echidnas, they're all mammals. And so, mammals did not look like this during the age of dinosaurs. Mammals basically looked like this. Basically, all of the mammals during the Mesozoic looked like little shrews and mice and voles and rats and etc. Just little fuzzy, snivelly things kind of running around in the shadow of the dinosaurs. A few of them got super huge by Mesozoic mammal standards, which means they got to be about the size of a loaf of bread. That's like the hugest mammal during the age of dinosaurs, is maybe like this. But they basically all looked like this. They looked like rats or shrews or voles or badgers. A few of them developed like, they almost looked like flying squirrels or something like that. But there were no monkeys or whales or camels or horses or bears or cats or anything like that. And it was only because of that asteroid impact that mammals actually diversified and got big and had all kinds of... All of the mammals that you think about today, none of those existed during the age of dinosaurs. Yeah. And in fact, most of the mammals back then laid eggs, too. We think. So yeah, a world without cats. Yeah, Fedorasaur. Yeah. Or pangolins or zebras or aye-ayes. There you go, Mayor Space. Aye-aye. Yes. So yeah. Yeah. It's over, Stegosaurus. I have the high ground. There you go, Dinosaur Dave. Yeah. But yeah. Yeah. And Samuel Gull has a question. How does the largest flying dinosaur fly? Its wings look pretty heavy or thick. Is that just an illustration error? Well, the largest dinosaurs to ever fly were critters like this. And this. Pelagornis is one of them, and Argentavis. There we go. Another one of the largest dinosaurs to ever fly. Birds are living dinosaurs. I think maybe what you're thinking of Semi-gull is instead pterosaurs. So pterosaurs are the flying reptiles. They are not dinosaurs. They're kind of like cousins to the dinosaurs. And some of them got absolutely enormous. Huge, huge, huge. But, yeah, and they would have been extremely lightweight. Extremely lightweight. Let me find you a clip to help explain this concept, because those wings might look heavy, they were not. Here we go.
Was capped by a lightweight but very strong skeleton. Berkeley paleontologist Kevin Padian is...
I just saw Kevin on Tuesday. I live right near Berkeley, everybody. I'm, those of you who are new, I'm broadcasting to you from the beautiful sunny San Francisco Bay Area, and Berkeley is just over there, or over there. Yeah. So, I have the opportunity to visit the Museum of Paleontology in Berkeley fairly often. I am blessed in that regard. But, yeah, here is Kevin Padian.
Berkeley paleontologist Kevin Padian is an expert on the evolution of flight and the anatomy of pterosaurs.
First thing to know about pterosaur bones is that they have the thinnest bones of any vertebrates. This
Incredibly
one's
thin.
Flat as a pancake, and it's like it was just like it was run over by an 18-wheeler sometime in the Cretaceous there in the middle of the ocean, right? And it's a this bone comes from the upper arm like this.
It's a humerus right there.
Completely flat. The bone wall is so thin, it's about the same dimension as the wall of a dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir in it. Well, that's what this thing is like, except there's nothing in the middle of it. I mean, it's just completely air-filled, and it's squashed flat, and the bone walls are very, very thin. Now, you might think this would make it a very weak bone, but in fact, we checked this out with some engineers at Stanford, and we're working with them, and they showed us that, in fact, the big diameter of this arm is what really makes it strong.
So they had incredibly strong bones, but also extremely, extremely light.
Girder.
And, here we go. Let's take a look at this from Prehistoric Planet. If you've not seen Prehistoric Planet yet, holy cow. Should you check it out. It's good stuff. Yeah.
While the land was dominated by dinosaurs, the skies were ruled by flying reptiles, pterosaurs.
Yeah.
They lived in every continent on Earth.
Yep, including Antarctica.
Some of them had extraordinary head crests, like this one, which belonged to a species called Barbaridactylus.
That's nuts, right? I mean, look at this. Look at that right there. Insane, right? So some of these guys had... This must have been something to do with reproduction, where, you know, the males with the longest crests like that were the ones who were able to reproduce the most. So you could just get this, like, runaway sexual selection there. So, yeah. Yeah. Pretty cool, right? Want to know what it did to their aerodynamics? It's a good question, Hannies. Yeah. Yeah. I think that's work that still has yet to be done. Like, how would that affect the way that they flew? I don't know, but we do know that they flew.
To a species called Barbaridactylus. Now, why would a flying reptile have a head crest as large and as cumbersome as that?
Yeah.
These strange, long, thin crests are among the most recently discovered of a wide diversity of bony crests seen in pterosaurs as a whole.
There's all kinds of different varieties,
20 different species, all equipped with differently shaped head crests. They range from short spikes and lumps to enormous bony sails, and now to these ridiculous crests that look like antlers and which are longer than the whole of the rest of the animal.
That's nuts.
The discovery of so many different pterosaur crests triggered a debate among scientists about what they were used for.
Yep.
Some of the ideas that we've had are, in some way, it's helping the animal to fly, maybe it's reducing drag. We've done some tests in wind tunnels, and all the studies have found that there may be a very small advantage to it, and if there is a very small one, then what's the point of putting such a huge structure on the back of your skull if it's not really helping you?
Yeah.
So it's got to be for something else.
An explanation
Okay.
of extraordinary head crests like this one may lie in the fact that the biggest are restricted to older male specimens. In living animals, where
Yeah, so this is sexual selection because of sexual dimorphism.
and the females lack them, you can be pretty sure it's a consequence of sexual selection.
Yep. Yeah. So anyway, cool stuff. I'll give you this link if you want to watch the rest of this. But yeah. Pterosaurs, pretty extraordinary creatures. They're not dinosaurs, but they lived at the same time as the dinosaurs. And they're kind of close cousins to the dinosaurs. If you want an image of that, this is a pretty handy little chart for determining what is a dinosaur and what isn't. The way that we classify living things as scientists is based on what we call phylogeny. It's based on their evolutionary history, based on what they evolved from. And so in order to be a dinosaur, you have to have evolved from this dinosaur ancestor. Dinosaurs are a group unto themselves because they all share a common ancestor. Pterosaurs are over here. They're just outside of the dinosaur group. So they're close cousins to the dinosaurs, but they're not dinosaurs themselves. Birds are dinosaurs because they evolved from that dinosaur ancestor originally. Theropod dinosaurs who developed feathers and stuff like that, like Velociraptor, are very close relatives of the birds. The birds evolved from the same ancestor that Velociraptor did, right here. That makes sense? That's also why crocodiles are not dinosaurs, because they didn't evolve from that same ancestor. You go back far enough, and dinosaurs and crocodiles both share an ancestor, but they're distinct. Crocodiles are like cousins of the dinosaurs, too. Does that make sense? Yeah. Anyway. Yeah. Oh, and Grim Deviant, I forgot to even talk about Godzilla today, but yeah, today's November 3rd, the anniversary of the release of the first Godzilla film, Gojira, 1954. We'll make a big deal about this next year, because it'll be the 70th anniversary of that film. Yeah. So next year I'll make a big deal out of that. But, Sculpin says, do beer guts count as crests? I think it depends on who you ask. But yeah, is Godzilla, if Godzilla actually existed, is it a dinosaur or a reptile? Well, if it's a dinosaur, it would also be a reptile. Because dinosaurs are a kind of reptile. Sauropsida starts off right here. Sauropsida. And dinosaurs, if you follow the nodes up, dinosaurs are a kind of sauropsid. So they are a reptile, if you want to use that term. I've heard people say Godzilla, at least in the Gareth Edwards 2014 movie, almost looks like a synapsid. In which case he'd be a mammal relative. But I know in the original films, in the what we call the Showa series for Godzilla, from the 1950s through the 1970s, and then in the Heisei series, the 1980s through 1990s, Godzilla is supposed to be a dinosaur. There's a lot of dialogue that refers to him as a dinosaur. And if you've ever seen the, let's see, the 1991 film, Godzilla vs. King Ghidorah, he is absolutely supposed to be a dinosaur. There's a... Before Godzilla gets mutated by the 1954 Bikini Atoll atomic tests, he is just a dinosaur lumbering around on this island. Yeah. And the, he ends up fighting American soldiers on this island. It's a wacky movie. It's really crazy. Yeah. It really is. Yeah. Yeah. It's pretty wild. Yeah, anyway. Yeah. This would be good for a sub-alert, Fedorasaur. I've already got that. As, like, 6 different alerts. Yeah. Yeah. They cut out the line there. Shoot, where was it? It's a dinosaur, a gigantic dinosaur. It's attacking our boys. Yeah, here we go. Yeah. Anyway, I have that as an alert, because how could I not? So anyway, I think of Godzilla as a dinosaur, but he's not necessarily a very good dinosaur. Like, I'm not commenting on Godzilla's personal character or anything. Godzilla's a personal hero of mine, obviously. But, yeah, he's not... Here, let me show you. Where did I put that book? My copy of Dinosaurs, the Textbook, 2nd edition, is... And I cannot wait to get my bookshelf reorganized. This is unworkable. Anyway, there's a little inset in that where it's like, Godzilla, a lousy dinosaur. And Godzilla doesn't really have a lot of the same features that we associate with dinosaurs. Which maybe is fair if he's been evolving in isolation for... Rather, if his lineage has been evolving in isolation. Not him individually. Individuals don't evolve. If his lineage has been evolving in isolation for 66 million years, then it would make sense that he would look really different. But, yeah, he just doesn't look particularly dinosaurian. There we go. Yeah. So,
Rampaging in an unsuspecting world.
Well.
From the dawn of time.
David Peterson.
What havoc will they wreak? What
What are you
lives
doing?
will they destroy? What depths of panic and terror will they create?
Thank you, David Peterson, for the raid. Welcome to Paleontologizing.
And their 58 raiders have arrived to wreak some sweet havoc.
It's good to have you here. Thanks for joining us. How was your stream?
Here's something stranger than science.
Hope it was really, really good.
Prehistoric fact.
Yeah, welcome to Paleontologizing, everybody, especially any new folks. Let me know if you got any questions. I'm Danny Anduza, dinosaur paleontologist. I just got a question as to whether or not Godzilla is a dinosaur. And the answer is, yes, he is supposed to be a dinosaur. But, not a particularly good one. I don't know. I'm not going to go into detail about this right now because I don't want to go down a great big rabbit hole. But yeah. And Sculpin5 gives some... Thank you, Sculpin. I really appreciate that. Thank you kindly. Thanks for supporting me and supporting Science Outreach here on Twitch, Sculpin. Anyway, David Peterson, how did your stream go? I hope it was really good. Raiders from David Peterson, how'd it go? Tell me about it. And welcome back to Paleontologizing. And thank you, Thick Momi, for the follow. Welcome to Paleontologizing. Yeah. Anyway. And Silent Kevin says, wasn't Godzilla originally meant to represent the fear caused by the atomic bombs? Bingo. Yes, indeed. Yeah. That original 1954 film is actually really somber and kind of gut-wrenching in a lot of ways. Only later would Godzilla, you know, because of changing cultural attitudes, he kind of became sort of a folk hero, you know, like friend to children, like kind of goofy, almost superhero-like character in the 1970s. So yeah. The one with Perry Mason, yeah, with, what's his name? Steve Martin was his character's name, but, Raymond Burr. Yeah, anyway. We'll be talking all about Godzilla next November 3rd, because that'll be the 70th anniversary of the release of the original film in 1954. Oh, yeah. And Nick Adams did one, too. This is true. That was, I think that was Invasion of the Astro Monster, 1962, I want to say? Yeah. And Steve Martin. Yeah, not Steve Martin the actor, but that was the character's name. In 1954. Or 1956, rather. Yeah. Yeah. Here we go. Take a look. Yep. So this is Steve Martin here. That's the character's name. Raymond Burr is the actor. High tension lines. These never work. Yes, indeed. Yeah. Don't want to play too much because Toho Limited Company, which owns the rights to Godzilla, is notoriously litigious to the point where I've had several alerts that are just like a second or two long, and the stream gets copyright struck because of those. So you got to be real careful talking about this sort of thing. Yeah.
Here's something stranger than science fiction. Prehistoric fact.
And Wiedolinsky Art, thank you for the follow. Welcome to Paleontologizing. An appropriate alert that you got there for your following. You an artist yourself? Welcome to the stream. It's good to have you here. Yeah. And Godzilla's skull, if that helps us classify it. Yeah, so this... I don't know if this is official or anything. But this would imply that Godzilla is a dinosaur because he's got the nares and then the antorbital fenestra right here. And then the orbit, the eye socket. And then this looks like it might be a post-orbital fenestra here, and there might be a temporal fenestra up there, so this would imply that Godzilla is a dinosaur if this skull is taken to be... I hate using this term because it sounds like it's in a biblical context or something, but like canon. If this is canon, then that would imply that Godzilla is a dinosaur. But I'm guessing this is something that like an artist put together and they based it on a dinosaur skull and tried to Godzillify it. So yeah. And you love the Mothra movie. It's a good one there. Raymond's. It's a good one. I used to know the whole Mothra song in English and Japanese and Malay back when I was a kid. Good stuff. Yeah. And Diagonal says, is Godzilla a thyreophoran? I think he's supposed to be a theropod, because... Yeah, but he's got some thyreophoran traits. Do I have that book over here? There was a Goofy book that was written in the early 2000s. And it chronicles a time when a paleontologist, it may have been Ken Carpenter, or it may have been someone else, a Godzilla fan. It was on April 1st, like 1999 or something like that. April Fool's Day, they published a paper and they're like, no, new super giant theropod. And like the idea is that they're like, oh, we discovered Godzilla, but it was an April Fool's joke. I don't know where that book is right now. Or I would show you. But yeah. But anyway. Yeah. And Je suis, you'll be back. I appreciate that. You have a great day or night wherever you are too, and hope to see you next time. Thanks for being here. Yeah. Now, speaking of big aquatic, toothy, sauropsid creatures like Godzilla, let's talk about this new mosasaur, shall we? Let's finally get to that, because I feel like it's been long enough. Let's get into it. Here we go. From Sci News, new mosasaur species unearthed in North Dakota. A new genus and species of mosasaur being named Jormungandr, and I am gonna need to look this up and see how it's pronounced. This is a word from Norse mythology.
Looking at how to pronounce the name of the Midgard serpent in Norse mythology.
Okay.
We are looking at how to pronounce Jormungandr. Jormungandr. Jormungandr.
Jormungandr.
Jormungandr.
Jormungandr.
Jormungandr.
Jormungandr. Okay. A new genus and species of mosasaur being named Jormungandr, valhallaensis, from Valhalla, has been discovered by the American Museum of Natural History PhD student Amelia Zietlow and colleagues. Very cool, and this is some exquisite art. We'll be talking about what makes this so cool in just a minute. This particular piece of art. But yes, mosasaurs are a group of large carnivorous aquatic reptiles. They're actually lizards. They're straight up lizards that inhabited all the world's oceans during the late Cretaceous, between 90 and 66 million years ago. They may have evolved to kind of replace the ichthyosaurs, which went extinct in like the middle Cretaceous. These creatures went extinct during the end Cretaceous extinction event, at the same time as the dinosaurs, except for birds.
Dinosaurs became extinct because they no longer knew how to love each other. Is that correct?
No, it's not true. What? Oh.
And I certainly wouldn't want our species to end the same way.
Yes.
Raymond Burr's character reappears in Godzilla 1985, but
It's got a
they
great
only
speech
call
in
him
that.
Mr. Martin because Steve Martin was a celebrity by then.
Exactly, Blue Laser to the Sky. I love the Godzilla series trivia. I'm almost embarrassed by how much I know about the Godzilla series. I could... Appreciate you, Blue Laser. In fact, there's a couple of things I feel like I should show you real quick. Can I find that book in time? Let's look up a picture. Better yet, I'll look it up on Thrift Books. The best book ever written about Godzilla, in my opinion, is this excellent, excellent book. Still one of my favorites, Godzilla on My Mind, 50 Years of the King of Monsters. Excellent book if you're interested in Godzilla and the history of the film series, kind of the cultural background, like a kind of a philosophical examination of Godzilla as a character and as a phenomenon and everything else. It's excellent. Excellent, excellent, excellent book. Can't recommend it highly enough. Good stuff. Good stuff. And written in a really entertaining way. To the point where, yeah, really entertaining. And I want to show you this too. See if anybody gets this joke. It sounds like we've got some Godzilla enthusiasts in the chat. Do you get it? Anybody get it? Visual joke for you there. I sculpted this and printed it a number of years ago. And, yeah. You need that 3D print file? We can see to that, Lenina. It only exists in one place in the world right now, and that's here in my office. Yeah. Anyway, yeah. I was so proud of that. Yeah. Anyway, back to a real-life monster here. This new mosasaur, Jormungandr. Shoot, what was it again?
Jormungandr.
Jormungandr. Jormungandr. Yeah.
It's pronounced Jormungandr.
Jormungandr.
Gandr. Jormungandr. But
Jormungandr. Okay. New mosasaur. The first mosasaur was discovered more than 200 years ago. This is true. And it actually holds a really, really important part in the history of paleontology. In fact, let's look that up real quick. I can find you a clip of when the first mosasaur was discovered, because it was a big deal. There we go. Scoot through. And there we are. Excellent. Turn up the volume. There you go.
And the financial support of viewers like
Too high.
you.
The story of dinosaurs in modern times begins in the 18th century in Holland, the city of Maastricht.
Well, not dinosaurs in particular, but mosasaurs in this case.
Once 70 million years ago, this was the bottom of a sea, a warm sea. And here limestone was formed.
Yep. Zool says, been reading about the lost, buried worlds like Antarctica and the Sahara Desert. In your opinion, what's the possibility of finding any dinosaur bones in these environments? Not possibility. They're both... We've got dinosaurs from the Sahara and from Antarctica, Zool. Lots of them. Lots of them. Yeah. Yeah. Charlie's Dragon says Antarctica. No, I mean, we've got multiple dinosaurs from Antarctica already. Antarctosaurus, Cryolophosaurus, Glacialosaurus. I'm sorry, Antarctosaurus from Argentina. Yeah. One of my favorite dinosaur illustrations of all time is by artist William Stout, and this is of Cryolophosaurus in early Jurassic Antarctica. Yeah. So yeah, and there's whole documentaries about this. Let me give you a link. There we go. There we go. Dinosaurs of the Frozen Continent. There we go.
Antarctica. A frozen continent at the end of the Earth. Almost devoid of animals and plant life.
What? Casey Snowart says, oh my gosh, I love William Stout. I didn't even say his name. Yeah, one of my very favorite artists of all time, Casey Snowart. And someone who's had a tremendous influence on me and my own artistic style. It's funny, just a couple weekends ago, I bought like 3 different William Stout art books on dinosaurs, and yeah. You're in good company, Casey Snowart. That's awesome. You got good taste. Yeah. Anyway, his Cryolophosaurus here, one of my very favorite dinosaur illustrations of all time. His style is something that I can only hope that my style would be half as cool as his. Yeah, here's Glacialosaurus, by the way, from Antarctica. There's his illustration of it. Yeah. This is new dinosaur discovered in Antarctica, but that's not as informative as it should be. Glacialosaurus was the first dinosaur discovered in Antarctica way back in the 1980s, but it wasn't until like 2006 or 2007 that it was actually published. Everyone thinks that Cryolophosaurus was the first dinosaur discovered from Antarctica, but nope. It was just the first to be published and named. Yeah. And Casey Snowart says he made me want to be a paleo artist, William Stout. But I eventually realized how niche that was. Oh yeah, it's hard to make a living. I went the book illustration route instead. Well, I hope you found success there, Casey Snowart. That's super cool. That's super cool. Awesome. Well, it's wonderful to have you here. Thanks for chiming in. That's great. Anyway, Antarctica, home to dinosaurs.
Millions of years ago, it was a land of great dinosaurs.
Like Cryolophosaurus.
Inhabiting a lush, forested ecosystem.
I'll give you a link if you want to learn more about Antarctic dinosaurs.
Antarctic predators hunted fleet-footed prey.
But where were we before? We were talking about mosasaurs. Let's get back to the original discovery of Mosasaurus in the first place, way back in the 1700s, I believe. Here.
For centuries, the people of Maastricht quarried this limestone for buildings.
And this is the namesake of the Maastrichtian stage of the Cretaceous. Someone pointed that out, and that's correct.
It was the year 1770. Quarrymen, working 500 yards from the entrance of one of the caves, unearthed something that made the rest of the crew lay down their tools and gather around in amazement.
Hey, you.
Over the years, they'd often dug up chips of bone, fragments of skeletons, but never anything so mysterious. They knew someone who would pay good money for their discovery, a retired military surgeon called Dr. Hoffman.
mining by torchlight. There you go, HD. Yeah. Yeah.
Dr. Hoffman was one of the first in a long line of professional and amateur scientists and bone hunters who have been fascinated by these secrets that the Earth yields up so grudgingly.
And Hoffman
hurried over to the quarry and was
he would eventually be named after him, Mosasaurus hoffmanni.
It appeared to be an enormous jawbone.
Oh, and thank you, Casey Snowhart. I'm flattered you've been lurking. I'm glad you chimed in, though. It's great to have you here. Yeah, there's those jaws. Mosasaurus.
He bought it immediately.
Here, have some coins.
"25 years later, the jaw of the monster attracted the attention of the French Revolutionary Army, who occupied Maastricht in 1795. They claimed the jawbone for France, where to this day it reposes in the National Museum of Natural History in Paris. Soon after the French Revolution, the National Museum was the scene of another revolution. This one led by a celebrated professional scientist, Georges Cuvier.
Cuvier, yes.
Professor of
We were
comparative
talking about him earlier.
anatomy, which was a booming branch of science at that time. And it was the very best place in the world for him to be, because I think the museum there probably had a larger collection than anywhere else in the world of skeletons and skins and, to some extent, pickled guts and so on, of a whole range of living species from all around the world. Like the other professors, he lived on the job. He had a house which went with the job, which was almost in the same grounds as the museum and the botanic gardens. And the botanic gardens included, as it still does, a small zoo. So he had access to at least a small collection of living animals which he could study and see how they moved, how they put their anatomy to good use. So he was in a very good position to understand the relation between bones and muscles and sense organs and gut and everything else within a living creature, and see how all those parts of the body contributed to a whole way of life.
Yep.
Cuvier had a theory. Huge bones had been found beneath the streets of Paris. They looked like elephant bones, except that they belonged to a creature that was clearly a different species, now called a mastodon. Cuvier reasoned that these bones belonged to an animal that had become extinct.
And it was really the first time that there was a really...
On the contrary, we stretch our understanding to try and take in the universe.
And Basim 2053, thank you for the follow. Welcome to Paleontologizing. It's good to have you here.
Good, pretty strong case for extinction.
Yep. So those jaws of the first Mosasaurus ever discovered, different scientists, they weren't called scientists at the time, they were called natural historians or natural theologians or natural philosophers. But what we would today call scientists, different scientists examined this and came up with different ideas. Oh, it's a whale. Oh, this is, some sort of ancient, mammal thing with teeth. But Cuvier thought, no, this is an ancient lizard. And there are no lizards around like this today. This is something completely different. This is something that's extinct. And that idea of extinction was revolutionary at the time. It was considered heretical, really. This idea that, living things could go extinct. It was groundbreaking.
Then one day, Cuvier turned his attention to the huge jawbone, the trophy from Maastricht.
And he compared it with living reptiles and concluded this time that it was an enormous marine lizard.
Cuvier had opened the door to a past buried far deeper than anyone had imagined. And the search he began has continued to this day.
Yes, indeed it has. So mosasaurs go way back in paleontology. There's some of the Mosasaurus in particular, as one of like the original, I hesitate to say legendary, but yeah, legendary fossil animals. It was a huge deal at the time, and it's really cool that we've got new mosasaurs today. Yeah. So after 200 years of scientific study, new mosasaur species are still being discovered as new localities are explored, and specimens collected long ago are reevaluated using modern standards of species delimitation, Zietlow and co-authors said. Even so, the phylogenetic positions of many key taxa are unresolved, and therefore our understanding of mosasaur macroevolution is muddled. But Jormungandr... Shoot, how do you say it again?
Jormungandr.
But Jormungandr. Jormungandr walhallensis lived in the Cretaceous oceans approximately 80 million years ago. Its fossilized skull and skeleton, cervical spine, and a number of vertebrae were discovered in 2015 in the Pierre Shale Formation in Cavalier County, North Dakota, United States. And some of you might be going, what? An oceanic animal found in North Dakota? Isn't North Dakota landlocked? Well, yes. Today, but not in the late Cretaceous. So this is North Dakota. Well, this is the position of it nowadays. You see it outlined there, but it was underneath a shallow sea. We call this the Western Interior Seaway, or the WIS. So in the late Cretaceous, sea levels were very, very high. And so low-lying areas were inundated by shallow tropical or subtropical seas like this. And so this is where this critter was swimming around at the time. Pretty cool, right? Undefined BH. I know, pretty neat, right? Isn't that cool? Yeah. So it's fossil. The species shows a mosaic of features seen in two iconic mosasaurs: Cleidastes, a smaller and more primitive form of mosasaur, and Mosasaurus, a larger form that grew to be nearly 50 feet long, 15 meters, and lived alongside Tyrannosaurus rex. Jormungandr. Is that right?
Jormungandr.
Jormungandr. Jormungandr is estimated to be about 7.3 meters, or only 24 feet long. So it's about half the size of the biggest mosasaurs, but it's still pretty big. And in addition to flippers, it had a shark-like tail and had angry eyebrows caused by a bony ridge on the skull and a slightly stumpy tail that would have been shorter than its body. As these animals evolved into these giant sea monsters, they were constantly making changes, Zietlow said. That's evolution, you know? If you're not evolving, it's because you're extinct. So if a lineage is still around, it has to be evolving. Yeah. And could it survive under frozen water? I doubt it. Has a new bookshelf. But it wouldn't have had to, because there was really no ice at the time on planet Earth. This is during, like, the Cretaceous hothouse. There would have been no ice up here at the time. It would have been an environment much like, let's see. Well, much like this right here.
And the tracks of the land's top predator.
Yeah. Tyrannosaurus. Going for a swim there.
Rex, taking a swim. Hollow air-filled bones and powerful hind limbs make T-Rex very effective swimmers.
Look at the little babies.
This is an adult male with his young family.
But uh-oh.
Giant marine lizard, over twice the size of a tyrannosaur and weighing over 15 tons.
Here comes a mosasaur, though.
It's the largest predator on the planet.
Larger than T-Rex. Yep.
Turtles are normally on a mosasaur's menu. But this brood would make a welcome snack.
Uh-oh. And that little one's lagging behind.
An adult T-Rex, even in water, could still defend itself very effectively. But the young must stay close.
Uh-oh. You'll have to watch Prehistoric Planet to find out what happens. But mosasaurs, I hope that gives you some idea of how big they got, the kind of environment they lived in, how formidable they were. Oh, yeah. Yeah. And when they said it lived alongside T-Rex, they meant it literally. I mean, yes. Yeah. Well, our new mosasaur, Jormungandr, I think that's how you say it. It lived before T-Rex, but that mosasaur lived at the same time. Yeah. Because T-Rex lived here in Montana, Wyoming, Colorado, and probably into Utah as well. Probably down all along the coast here. But that would have been 66 million years ago. And thereabouts. When the seaway had started to close up a lot. Yeah. So yeah. And there's no remains of any mosasaurs with digested tyrannosaur remains in them. No. So yeah. Yeah. Atreus says you can't find digested anything in a fossil, unfortunately. No, sometimes you can. We get gut contents. Yeah, it's happened in a lot of instances before. Sinosauropteryx is a good example. This really famous fossil here. And, was it Sinosauropteryx or was it Sinornithosaurus? Might have been Sinornithosaurus. Oh, there we go, yeah. Oh, wait, nope. So the possible Sinosauropteryx specimen GMV 2124 was also found with 3 mammal jaws in its gut region. Yeah, so Zangheotherium and Sinobatar, showing that these 2 mammals were part of the animal's diet. So yeah, gut contents are a thing in paleontology for certain. And sometimes we can tell, like, what a creature is eating based on the remains of its last meal there in the guts. That doesn't necessarily show you that that was, like, a regular part of its diet, because after all, the animal did die immediately after that. So if the animal died in like a drought or a famine or whatever, maybe that's not the things that it's typically eating. Its last meal. But in this case, it probably was, given that these dinosaurs died in due to like a volcanic ash cloud, we think, and not because of a drought or a famine or something. So that probably is pretty indicative of what these animals were eating. Yeah. Atreus says, I didn't realize that was possible. Thought all the material would be gone. There you go. That's why you come here to Paleontologizing. Yeah. Have those assumptions challenged. Yeah. I didn't mean to jump down your throat, Atreus, so thanks for being a good sport. I appreciate you. Thanks for being here. Yeah. But yeah. For similar reasons that we can't carbon date. I mean, this stuff is still fossilized, obviously. But there's the fossilized remains of those mammals in the gut of this animal. So yeah. 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 Basim says, what do you think is the most mysterious question in paleontology? That's a tough question, Basim. I think lots of aspects of behavior are very mysterious, trying to figure out how creatures behave just based on fossil evidence. But also, I think trying to... That's another thing that's difficult. Trying to actually delineate the difference between different species can be very difficult in the fossil record. If two critters look very, very similar to each other, being able to determine, are they the same species or are they different? That's the sort of question that gets me really excited and I think is a really difficult one. Like, it's a tricky question, and that's what makes it so appealing to me. Because when you're only dealing with very fragmentary remains of just the skeletons of some of these creatures, if you can't look at their soft anatomy, you can't look at their external appearance, you can't look at their DNA or anything like that to tell if they're the same or different species. To me, that sort of thing is really interesting. Yeah. And there you go, Canis Dalcata, exactly. Yeah. Yeah. But yeah. Yeah. And I'd be fascinated by how many single specimens, how many species are juveniles of others. Yeah, Death of Barney, that's a huge part of what I'm interested in, too. Ontogeny. Anyway, let's get back into our mosasaur here. Yeah. So this work gets us one step closer to understanding how all these different forms are related to one another.
Ontogeny.
The researchers suggest that Jormungandr, what is it?
In English it is Jormungandr.
Jormungandr. These researchers suggest that Jormungandr, Walhalla was a precursor to Mosasaurus. It may have actually evolved into Mosasaurus. This is a fossil coming from a geologic time in the United States that we don't really understand, said Dr. Clint Boyd. Yeah, Clint Boyd, who works on Thescelosaurus, oftentimes. Paleontologist at the North Dakota Geological Survey. The more we can fill in the geographic and temporal timeline, the better we can understand these creatures. The tale of Jormungandr, Walhalla paints a wonderful picture and helps contribute to our understanding of the northernmost regions of the interior seaway, especially with the mosasaurs, and discoveries such as these can pique scientific curiosity, said Dr. Nathan Van Vranken. This is the paper. All right, here, let me copy this link for you. There you go. Here is a link. And it says now downloading. I might have to go to my downloads folder to get it. There we go. Good stuff. Hooray for an open access paper. No paywall. Jormungandr walhallensis, a new mosasaurine from the Pierre Shale Formation of North Dakota. Good stuff. Oh, and Clint Boyd is an author on this. Nice. Yeah. Mosasaurs are large, carnivorous, aquatic lizards. Well, they are straight-up lizards, with global distribution that lived during the late Cretaceous. And figure 1, this is a wild figure to have in a scientific paper. Thor slaying the dragon, painting by G.A. Gullickson, on a scene of Norse mythology in which the world serpent, Jormungandr, battles against the god Thor. Original painting on display in the North Dakota Heritage Center and State Museum. That's a wonderful museum if you ever get the chance to visit, and it's right close to the state capital of North Dakota, which, this is the state capital of North Dakota. It does not look like a Capitol building. North Dakota is an incredibly small state in terms of population. Yeah, I think there's only like 700,000 people who live in North Dakota. I don't know. What is the population in North Dakota right now? Not very many. So yeah. It's, it looks like a grain silo, says Will62. Anyway, but the North Dakota Heritage Museum is like across the street from this in Bismarck, North Dakota. Yeah. So the Heritage Museum is like across the street. Yeah, there you go. There literally is. There's the museum and there's the Capitol building. Ah! Yeah. And Basim says it looks like a nice state, actually. It is. I like North Dakota. I've spent a lot of time in North Dakota. At the Badlands Dinosaur Museum in Dickinson, North Dakota. It's no California, obviously. You know, very few places are. In fact, only one place is California. That's where I live. I love it here. But North Dakota's nice too. It's a very different kind of place. Very wide open, not a lot of people, but there are some beautiful fossils from there. They used all the architecture points in the museum instead of the state capitol. There you go, Charlie's Dragon. Yeah. But yeah. And the North Dakota population, less than 775,000 people. That's crazy, Casey Snowart. Wow. Yeah. Shoot. There are literally more people who live in San Francisco. Little San Francisco, just 7 by 7 miles, than in the entire state of North Dakota. And North Dakota is not a small state in terms of geography. It's wide and big. So yeah. Very owned bicameral legislature. Yeah, there you go, Mayor Space. Yeah. And that's why our houses are cheaper here in the Midwest. That's true, Atreus. That is true. Yeah. Yeah, Fresno's population is just below. Isn't that crazy, Otter? Yeah. Wild, right? Shoot, there was a video I saw the other day that talked about really low population density in the Rocky Mountain and Plain states in the U.S. and how the population shoots up once you go across the border into Canada. We'll look at that another time when I'm talking about Montana and how few people live there. But yeah. Anyway. Back to our paper here. That's cool that this original painting is there in the North Dakota Heritage Center and State Museum. Nice. There's probably a lot of like Norse heritage in North Dakota, because there were a lot of European immigrants. Maybe not a lot of European immigrants, but many of the immigrants to North Dakota are of Northern European ancestry. Yeah. And Atreus says, "Can you explain the notation on that image? This one here?" Yeah, I'd be happy to. So this right here is the right maxilla. Maxilla is the upper jawbone up here. Up there. This is the premaxilla. PMX stands for premax. This is the left maxilla, so another one of the upper tooth-bearing jawbones. We've got the frontals right here, designated F. We've got the prefrontals left side. We've got the right pterygoid, the right jugal, the left splenial, and the left dennary. The dennary is the lower jaw, which also bears the teeth. So these are all just abbreviations for the different skull bones, if that makes sense. Yeah. Axman says, my mother's family are Norwegian immigrants in North Dakota. Cool. Yeah. And, yeah. Dan the BC man says, how did I get from an art show to a show on U.S. history? This is ancient U.S. history here, my friend. This is when the U.S. looked like this, when there was a big seaway running through the middle of it, and giant marine carnivorous lizards swimming through that, like this critter here. Jormungandr is the critter's name. Yeah, they've got some beautiful material. Really nice skull bones here. Skull bones are the ones that you want if you're going to describe a new species. That's pretty cool. Yeah. And here's where it is from, in the northern part of North Dakota. Right up there just south of the Canadian border. From the Pierre Formation. The Pierre Shale. Pretty cool. Pretty cool. So at this time, there would be all kinds of different weird critters swimming around doing their thing in the western interior seaway. Let me find you another prehistoric planet clip about mosasaurs here. Here we go. Take a look at this.
Nutrients driven up from the ocean floor ensure a plentiful supply of fish. Streamlined bodies and 4 powerful flippers give elasmosaurs great maneuverability. But their daily feeding forays make their movements predictable for an intelligent and patient hunter. Mosasaurus is an ambush predator.
So this might be the descendant of Jormungandr.
This enormous animal uses its huge tail to accelerate with astonishing speed.
Yeah. And he says fish haven't changed much. I mean, to a fish scientist, they've changed a lot. If you're an ichthyologist looking at these fish, you'd be like, whoa, they look weird. But, yeah. But overall, like on the outside, they don't appear to have changed a whole great deal, I suppose. Because they don't really have to. Like, you know, they're still doing the same job that they were back then. So externally, they're not going to change that much. Yeah.
This time, unlucky.
Look at that fishy fluke on the end of the mosasaur tail. It's pretty cool.
In fact, most...
And Murph, yeah, competing with all the other big predators in the western interior sea.
So many elasmosaurs living here, it's not long before there is another opportunity.
And if it works, it works. If it ain't broke, don't fix it, Baja Smancer. Yeah. Yeah. Beyond little tweaks here and there. Dinosaur Dave says, do we have any soft tissue showing that tail? We do.
The dark canyon floor, the mosasaur can approach unseen.
Ooh, uh-oh.
Waiting for a young, inexperienced individual. The ideal victim.
Oof. Nuts. Look at that. R.I.P. that elasmosaur. Oh. Yeah.
Mosasaurus can strike their prey with such force that the impact alone can kill. It's an attack so swift, the elasmosaur almost certainly never saw it coming.
Yep. At least it was quick, you know? So we've got evidence not just of mosasaurs feeding on things like elasmosaurs, but also feeding on turtles, feeding on ammonites. and feeding on other mosasaurs. And this image here, from this paper, illustrates that. So here is one of these mosasaurs attacking another one. I don't know if it's meant to be feeding or just like in a territorial battle or what. But, pretty darn cool. And then eagle-eyed viewers here might notice something interesting going on the throat right there. This is a really, really neat tidbit, I think. And can I find this on Twitter? Let's see here. If anybody's going to retweet this, it's going to be Thomas Holtz, I think. So let's see if it's on here. There we go. But what about the close-up of the art? Let's see. Let me grab this and do a search real quick. Here we go. Oh yeah, oh shoot, Richard Carr. Richard and I went to Montana State together. Takes me back. But he says, I don't read Norse. Does this say something? So this, let's go close in. Right there. This would be what you might call in media an Easter egg, potentially. That the artist put in here. Do those look like Norse runes or something like that? Ah! Yeah. And, yeah, looks like that to me, which is pronounced like Jormungandr. Jormungandr. So I'm going to assume it's the young Futhark spelling for Jormungandr. Tamil says, if you read this, you're too close. Pretty neat. Pretty neat. That's pretty cool. That's pretty cool. So yeah. It's subtle, but it's there. And I think that's a really neat little touch. So, welcome. New mosasaur. How do we say it again?
Jormungandr.
Jormungandr. Welcome to the world, Jormungandr. Or rather, welcome back. Pretty cool. Pretty cool. Fun fact, it literally just translates to big snake. I like that, Rahab. I like that a lot. And you got a new name, Rahab Mahakala. Very nice. Mahakala. That's a theropod from the Gobi, right? Yeah. Very, very cool. Very, very cool. Now that we finally covered our new mosasaur, do we want to do our Who Wants to Be a Millionaire now? I've been streaming for over 4 hours at this point. Do we want to go quickly through our millionaire game? Do a review and see if you folks can win the $1 million? Let's see. Let's do it? All right. All right, let's do it. Without further ado, we are going to do some Who Wants to Be a Millionaire, a review quiz game for all of you lucky viewers We're going to be talking, well, I'm going to have a bunch of questions pertaining to things that we've talked about over the past 2 weeks. And if you have any general knowledge about vertebrate paleontology and other aspects of science too, you'll probably do well in this also. So without further ado, let's start it up. Well, 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 everyone. Welcome to Who Wants to Be a Paleontologist? This is our semi-weekly quiz review game, where we're going to be seeing how much everybody has been paying attention over the past, I guess, 2 weeks now. So let me get this set up real quick, and then we'll go ahead and get into it. All right, here's how this works. The actual nuts and bolts and mechanics of how Who Wants to Be a Paleontologist will proceed. You will be presented with a question, which you will see here on the screen. You will read the question, and I'll read it to you. You'll have 4 potential answers. The way that you select your answer is by typing that letter into the chat. We'll see if chat can agree on what the answer should be. We're going to go with kind of a general consensus. It's kind of loosey-goosey, but I'm going to be sort of taking chat's temperature on these. And we'll see if cooperating together, all of you can win the $1 million. So without further ado, let's go ahead and get into our first question. For $2,000, the first question is: the famous crater resulting from the asteroid impact that ended the Cretaceous period was found where? Was it A, Arizona, B, Baja California, C, the Gulf of Mexico, or D, Italy? What do you think, chat? I'm seeing a lot of C's so far. MJD820 says C. Welcome, MJD. Good to have you here. Well, well, well. Arizona, Baja California, Gulf of Mexico, or Italy? What do you think, chat? What do you think? I'm seeing a lot of C's, and that's all I'm seeing so far. Good stuff. You know it, but don't want to say. You should say, Monkey Rig. That's what this is all about. Yeah. So chat's saying C, the Gulf of Mexico, is where the KPG impactor fell. Well, if you're so sure, is it your final answer, chat? What do you think? Yes? No? Yes? No? Yes. And of course, you are correct. The crater is indeed in the Gulf of Mexico, right on the tip of the Yucatan Peninsula. In the Gulf of Mexico. See if we can find you a video clip talking about this. We watched this on Halloween night, actually. And here we go. I'm looking for this particular clip to show you. And yeah, it should be about here.
It was Hildebrand who eventually followed up Penfield's work.
rock samples from the area Penfield identified showed all the signs of a high-energy impact.
Yep.
And it was full of shock quartz, too. So this evidence finally convinced everybody that indeed there was a big crater buried on the Yucatan Peninsula.
Yep.
After years
there
of
you go.
speculation, the crater had finally been found. It was named the Chicxulub crater, after a village built over its center.
Pretty cool.
The discovery of the Chicxulub crater was the ultimate evidence of the asteroid impact, and it tied together all of the clues that had been gathered over the previous decade.
So there it is right there. Extraordinary. It's even visible on the land today if you know how to read the clues. Pretty cool stuff. So nicely done, chat. Very nicely done. $2,000 in your pocket. You ready to double that for $4,000? I think you are. Let's do it. For $4,000. What is the closest living relative to the extinct woolly mammoth? Is the answer A, the African forest elephant? B, the African bush elephant? C, the Asian elephant? Or D, the elephant shrew? What do you think, chat? What do you think? All of these creatures are related to the extinct woolly mammoth, but what is the closest living relative? Claire. We're getting some more C's here. Asian elephant. Well.
Really spectacular. Spared no
And thank you, Lenina, for gifting Plockman's mustard there. I appreciate that, Lenina. Thank you, thank you. Good stuff. Let's chat if you want to go with C. Asian elephant. Is this your final answer? $4,000 on the line here. And Dan the BC man says it's either A or C, so I go with C. Let's see. And of course you are correct. It is the Asian elephant. Is the closest living relative to the extinct woolly mammoth. And like current resurrection experiment plans for bringing back the woolly mammoth. People like George Church and the Colossal Biosciences team and them, they're basically trying to take an Asian elephant and basically change its genome so that it looks like the genome that we've since decoded, or have before decoded, of a woolly mammoth, Mammuthus primigenius. But, yeah. That's phylogeny right here. We've got the woolly mammoth, ancient mammoths here. Asian elephant is the closest living relative, and the African savanna elephant is the outgroup there. So yes, indeed, you were correct, chat. Asian elephant is the right answer. You ready for the next question? Well, well, well. Oh, Dan the BC man wants to know, what is an elephant shrew? Oh boy. Let me show you. Elephant shrews are related to elephants. They're also called sengis. Here, take a look at this.
The animal is just waking up under
Rip. And Nat Geo, I might get copyright struck for this. Shoot. So let's go and do this. And I gotta turn closed captions off. Yep. Yep. Oh. So this is from a group of animals that we call Afrotheres. Afrotheria. And, let's see. Here, take a look at
If you
this.
were to ask the average person what an elephant, an aardvark, and a manatee had in common, they'd probably be scratching their heads. Of course, they're all mammals, but they also belong to an order of animals known as Afrotheria. This
Yep.
group is an ancient lineage of mammals that encompasses a wide variety of species of different sizes, shapes,
Like the
and
elephant shrew down there.
Afrotheria
Sengi.
is speculated to have first emerged during the mid-Cretaceous period, roughly 105 million years ago. Africa, which had previously been connected to South America, began to split apart due to plate tectonics and was isolated from the rest of the world for about 65 million years. This extended period of isolation resulted in the mammals that are inhabiting this continent to go through their own unique processes of evolution. The extinction of the dinosaurs at the end of the Cretaceous only allowed for a greater radiation of different and unique forms. Today, Afrotheria consists of 6 different orders: Macrosqueletia, Afrosauricida, Tubulidentata, Hyracoidea, Proboscidea, and Sirenia. The first 3 of these orders make up a larger family known as Afroinsectophilia, and the latter 3 belong to a group known as Paeongulata.
So anyway.
Afroinsectophilia consists of smaller insectivorous mammals that live on the continent.
Let's just get into Tree of Life here real quick, and I'll show you that elephant shrews are very close relatives of elephants, at least in the grand scheme of things. Sengis, like the... There we go, elephant shrews, Macrosqueletia. There we go. There's the elephant shrews. They look like this. Also, probably more properly called Sengis. But they are related to things like tenrecs and golden moles. You zoom out further. And they're related to dugongs and elephants. So, the closest living relatives of elephants, I think, are hyraxes or dugongs. I guess it's dugongs and manatees, yeah, are the closest living relatives of elephants. But hyraxes are a little bit closer to elephants than sengis are. There's a hyrax right there. They're cool critters. But anyway, the point is, chat, you got that correct. So, nicely done. And yeah, tenrecs, aren't they cool, Casey Snowart? They're very, very cool animals. And Rahab says, evolution is like a drunk artist sometimes. Sure. But those critters all look so different from one another because basically all of the in-betweens are extinct. You might otherwise have, like, kind of a smooth gradation. Lots of, like, species that kind of look almost like they're intermediates, but those have died out. And so now you're left with such different creatures as elephants, manatees, and hyraxes that are all each other's closest living relatives today, because all their relatives are gone. So yeah. Anyway, you ready for the next question, chat? I think you are. For $8,000, let's get it. This comes from our Sawfish stream from International Sawfish Day. Which state is home to the last surviving population of sawfish in the United States? Is it A, North Carolina, B, South Carolina, C, Louisiana, or D, Florida? What do you think, chat? What do you think? We did a whole long stream, really fun stream, on sawfish, genus Pristis. Mayor Space is D. Hashtag Florida Man Gang. Well, well, well. D. Chat is pretty well set on D here. Yeah. Oh, and that's cool, Alex Rickson. Thanks for looking that up. The Old Norse spelling of Jormungandr. Interesting. Cool. Well, chat says D for Florida. Florida's got a lot of cool things going for it. Like, biologically, zoologically, but botanically, Florida's a really interesting state. But are they that lucky to have the last surviving sawfish population in the U.S.? Let's see. Chat wants the D. Is that your final answer, chat? Let's see here. And of course, you are correct. It is true. Florida is the last place where you can find sawfish in the United States. They used to range all up and down the coast. But nowadays, they can only be found in Florida. And I'm trying to find you that video here. I might have to go back into my notes and find that. There it is. Excellent.
A weird looking fish that, you know, a lot of times people would keep them and take pictures and show their friends.
Habitat.
What an incredible creature. I love sawfish so much. They're so neat.
Major funding for this program was Adventure.
Historically, sawfishes were a common tropical species worldwide.
There are 5 species globally. Around the turn of the century, 1920s, 1930s, almost all the species of sawfish globally began to decline.
Yeah.
Today, all the species of sawfish are listed as either endangered or critically endangered by the International Union for Conservation of Nature.
Yep.
We're in danger of losing an entire family of large tropical shallow water predators that are one of the major components of the tropical ecosystems where they live.
And they're different from saw sharks. Sawfish are actually kind of ray. There we go. But this is the clip I was trying to find. So you're right there, Hennies. Yeah, they are a kind of ray.
Small-toothed sawfish once ranged from as far north as New York to the Texas-Mexico border.
The center of the distribution of small-toothed sawfish has always been Florida in the United States. A lot of those far-reaching records were probably stray animals.
By the 1980s, the population had contracted to South Florida only.
Yeah.
Fishing played a large...
So that's the only place that you can find sawfish nowadays in the U.S. is in Florida. So if we have any Florida residents here in chat, you should be proud of that you still have sawfish there. And it is partly your responsibility to help inform your fellow Floridians of what these remarkable creatures are and how we can protect them and all that good stuff. And by the way, here is my sawfish rostrum that I 3D printed for that stream and future streams too. Good stuff. Yeah. Anyway. Congratulations, chat. $8,000 in your pocket right now. You ready to double that for 16? I think you are. Let's do it. Your next question for $16,000. The humpbacked carnivorous Spanish dinosaur, Concavenator, is known from how many specimens? How many skeletons do we have of this critter? Is the answer A, 1, B, 2, C, 3, or D, 11? What do you think, chat? Getting a little bit trickier here. We were talking about Concavenator on Spain's National Day when we were talking all about Spanish dinosaurs. How many specimens do we have of this remarkable critter? I'm seeing some A's in chat. A. Not enough, says Phalo. Agreed. Yeah. Be lovely to have more specimens of this remarkable animal, but chat, if you're sure, we can go with A for one. Is that your final answer, chat?
Hold on to your butts.
Let's go for it. And of course, you are correct. Very nicely done. Concavenator is indeed known from only one specimen. The majority of dinosaurs that have ever been named are known from but one specimen, including the remarkable Concavenator. Really cool critter. Really cool critter. And let me show you here. There is the original type specimen. It is beautiful. We've only got one. Just this one. There we go. Let's see. The type species is Concavenator corcovatus. The fossil was discovered in the Las Hoyas fossil site. I'm looking for where it says that there was just one that was discovered, but you might have to trust me on this one. There is only one that has been discovered. Anyway, just one for Concavenator. Here's a link to the article if you'd like to read that yourself. Yeah. Henny says, is the hump for energy or water storage? Doesn't seem like it. No. It seems to be more of a structural thing, honestly. Maybe to help hold up parts of its body, almost like the towers on a suspension bridge or something like that. But anyway, we're not going to get into that right now. We are going to continue because I got things I got to do tonight. Let's get to our next question here. For $32,000, holy cow. Your question is, which TwitchCon science panelist actually dropped out of high school on their way into a career in the sciences? Those of you who watched the panel discussion might know this, or maybe you've picked it up elsewhere, but interesting origin story here. Who dropped out of high school on their way into a career in the sciences? Was it A, Science Streams, B, Volcano Doc, C, Nerduino, or D, Paleontologizing? What do you think, chat? What do you think? We're getting some B's here. B, 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 B. Well, you think it's Volcano Doc, chat? $32,000. This isn't minor leagues anymore. This is some serious cash. You sure? Skipped a lot of school. Wasn't that much, Claire Burr. Just every now and again. Senior year. But if you think it's B, Volcano Doc, is that your final answer? Yes. No, yes. Let's say yes. And you are correct. Of course you are. So our very own Volcano Doc from twitch.tv/VolcanoDoc. She indeed dropped out of high school. On her way into the sciences. And I'm trying to find that clip here.
Once we knew only that they vanished.
And Paleostream.
Dinosaurs ruled the land longer than any creature before them or since.
Welcome, welcome, Paleostream and Raiders. How are you all doing?
Raiders want to know more than that.
I appreciate that very much, Paleostream. Welcome, welcome to Paleontologizing. Holy cow. We're in the middle of a game of Who Wants to Be a Millionaire, or rather, Who Wants to Be a Paleontologist right now. So, I'm glad you could be here. How did the art go tonight? Paleostream, I hope it was really, really good. Thanks for the raid. And welcome, new folks, to Paleontologizing. Petite Paleo Artist, it sounds like you're in the right place. Welcome, welcome to Paleontologizing. Fangly Can, Shamu the Orca, and Paleostream. How are you all doing? Hope you're having a great day.
I'm a paleontologist.
And Petite Paleo Artist, thank you for the follow. Welcome, welcome. Shoot. My name is Danny Anduza. I'm a dinosaur paleontologist. So I study dinosaurs. I publish on them in the scientific literature. I dig up dinosaurs. This summer I was working in western Wyoming and eastern Utah in the Cretaceous and the late Cretaceous and then the early Cretaceous. The late Cretaceous Almond Formation and then the earliest Cretaceous Cedar Mountain Formation. Working with the Utah Geological Survey. Digging up some new hadrosaurs, new ceratopsians, new iguanodontians. Yeah, it was a lot of fun. Check out the YouTube page if you want to see the live stream recordings of those, because I was streaming that live on Twitch. Anyway, if any of you are not yet following Paleostream, if you were here in my channel before that, before this raid, go follow Paleostream right now. Do yourselves a favor. Joshua Knupe is a German paleo artist, and he's had some recent publications of his art. Really, really cool stuff. His channel's always a fun place to hang out. You know, he's got friends that he hangs out with there, and they talk over voice chat on the Discord as he's doing paleo art live. It's always a good time. So thank you, Paleostream, for the raid. I really appreciate it. Yeah. We are playing right now a game of Who Wants to Be a Paleontologist? This is our Who Wants to Be a Millionaire knockoff. This is our weekly review game. Semi-weekly. It's been a few weeks. But, yeah. We were talking about the TwitchCon panel from TwitchCon a couple weeks ago. Unfortunately, it was the same weekend as SVP. And TwitchCon paid for my ticket. So I went to TwitchCon. SVP would have cost me so much money this year. But, anyway. I'm trying to find this part where Volcano Doc talks about her background. And I believe that is right here.
I'll address ants. So we get to look at that live on the stream. There's also mosquitoes.
There we go.
No, I started streaming during the pandemic as well. I was actually teaching a natural hazards and disasters course at the university I was at. And I started...
And maybe it was earlier than this, actually, where we're all kind of introducing ourselves at the beginning.
At least 3 news multiple times.
Or...
Again, one of the coolest things is that we, on an educational platform that's usually used for games.
Yeah.
My name is Balint. I'm actually 1/3 of Science streams. I'm an ant geneticist. We run the channel with my wife, who's also a molecular biologist, and our 9-month-old daughter.
All right. And then we've got Volcano Doc here, who is the answer to our question.
Dr. Melissa Scruggs. I'm Volcano Doc everywhere, and I study the chemistry of magmas and try to understand what makes volcanoes erupt. I am so appreciative of Twitch just for existing and giving us this space, but also for all of you. If you're not new, or if you're new to me or never met me before, I would have not been able to finish my PhD without my Twitch community and everybody's support and encouragement, and I'm just so appreciative of all of you guys for coming today.
Oh, and I guess it wasn't right there that she talks about it. It would have been here.
Well, I'm a volcano scientist. No, I started streaming during the pandemic as well. I was actually teaching a natural hazards and disasters course at the university I was at, and I started recording my lectures. And
Paleostream says, very fancy shirt today. Thank you. Appreciate that, Paleostream. Yeah.
I love being able to.
I wear this when we do Millionaire.
I can see the world, and so here at the, I don't know if it'll animate, but the second one, that is what oh no, you can go.
Here we go. Let's scoot through a little bit. Was it here?
Of the plume overlays and
no, it's not a big issue.
Anyway, trust me on this. If you watch the video, oop, hang on a second. There we go. Volcano Doc actually dropped out of high school on her way into a career in volcanology. Really interesting story. And hopefully one of these days we can raid into Volcano Doc. And those of you who have not yet followed her, which you all should follow her, absolutely. A live volcanologist here on Twitch. Her stuff is super interesting. Her streams are always a lot of fun. I wish she had the chance to stream more often. But go follow her so you get notified of when she's live. Yeah. Anyway, her point in bringing that up was to show that many different kinds of people can become scientists, and there are many, many different paths into science. I think it's a really important message to tell people. So yeah. Anyway, ready for the next question, everybody? I think you are. Let's go for it. For 64,000 bucks. Oof. Those of you who came in through Paleostream, you'll probably do really well in this. As the animals with the most neck vertebrae of all time, Elasmosaur's cervical vertebrae count could stretch to. They could have to up to how many vertebrae? Is it A, 33, B, 41, C, 52, or D, 76? How many vertebrae just in the neck? Only cervical vertebrae for Elasmosaurs. Will62 says A. Alex Vixen says D. D from Golganak, D from Shamu the Orca, D from Peter Steves. We're seeing some more Ds here. And he says, wait, they could have variable amounts? Different Elasmosaurs had different numbers of vertebrae, yes. But what's the highest count that we have from an Elasmosaur? I'm seeing some more Ds here. D for 76 for Elasmosaurs. And keep in mind, this is not Elasmosaurus itself. This is the entire family of Elasmosaurs. D for dang, that's a long neck. Go Golganek. Well, chat, if you want D, is it your final answer? You seem pretty sure, chat. So let's go for it. And of course, you were correct. Yeah. And Paleostream in particular, very nice, knows this, I guess, off the top of his head. I'm impressed, Paleostream, yes. Elasmosaurus, I think, has up to 72. Albertonectes. It's got neck right in its name. Albertonectes can have 76 vertebrae. It's probably another one of those critters that's only known from one specimen. but it holds the record for the longest neck of any plesiosaur and the most vertebrae. Yeah. The discovery of Albertinectes marks a new record in both neck and total body length among known elasmosaurs. And if we go to the Elasmosaurus article, I know because I looked this up this morning. I believe that reference is right in here. There we go. Elasmosaurus differed from all other plesiosaurs by having 72 neck or cervical vertebrae. More may have been present, but they were later lost to erosion or after excavation. Only Albertinectes had more neck vertebrae, 76. And the two are the only plesiosaurs with a count higher than 70. More than 60 vertebrae is very derived for plesiosauria. So, nicely done there, chat. Nicely done. $64,000 in your pocket now. You've got just 4 questions left until you win that million, if you win that million. Let's see if you can do it. Ready for the next question? I think you are. Let's get into it. For $125,000, that's an eighth of a million there. Your question is, which of the following is true of the California sheephead? That is Semi-Cocyphus pulcher. This is a marine fish found off the coast of California. We were talking about this just the other day. Which of the following is true about it? Is it A, it is actually a sheep? B, individuals are all born female? C, it can count to 28. A fish that's good at math. Or D, it can swim up waterfalls. What do you think, chat? What do you think? It's obviously D, says Dinosaur Dave. Lots of waterfalls flowing into the ocean. Of course it's going to swim up those. Has D ever been tested? Not to my knowledge, Murph. I honestly don't know of many waterfalls that flow directly into the Pacific Ocean. Well, chat seems pretty set on B. Individuals are all born female. How in the world do they reproduce? Well, chat, if you're so certain, we can go with B. If that's your final answer, I suppose we can do this. How to do it says I learned it at the Monterey Bay Aquarium. My favorite aquarium. Very nice. And you are correct, of course. Congratulations. $125,000 in your pocket right now. Very nice. So let's talk about that a little bit. The California sheephead is a remarkable actinopterygian fish in a lot of different ways. And they are pretty cool critters.
Take weeks to
Here's what they look like.
Docile and curious nature makes them a popular target for spearfishers. Normally, individuals will mature as females at 4 years of age and change sex at around 31 centimeters in length and 8 years of age.
Yep.
The age of sex change can vary. Populations with higher survival rates have been observed to reach larger sizes before sex change. Sex change occurs in the winter months. The transition
Pretty interesting,
can take
right?
weeks to months to complete.
It's really cool, the different adaptations,
Results in changes to the sheephead size, color, and jaw
that
structure.
the different organisms
Red in
evolve.
color, while males have a more prominent forehead and distinctive red band. Males are larger.
It does make me wonder. It does make me wonder if we could ever spot this kind of thing in the fossil record. If we would ever actually be able to determine this from fossils. It's the sort of thing that keeps a paleontologist up at night, you know? But, yeah.
Reach 3 feet in length. These fish are carnivores that feed mainly on sea urchins and mollusks. They are important predators to kelp forests by regulating the sea urchin populations. Sea urchins graze on kelp, and excessive grazing can demolish a kelp forest. Female California sheepheads have been observed using rocks as tools to crack the shells of sea urchins.
Ooh, and right there, that's the Garibaldi sneaking on the side, trying to get some scraps. That is our state marine fish here in California. Our official California state marine fish is the Garibaldi.
Have been observed using rocks as tools to crack the shells of sea urchins open for easier feeding. Males.
Anyway, so someone was asking, do all the females eventually become males? No. It's only after reaching a certain size and a certain age that females can transition into becoming males, where they like start producing sperm and stuff like that. So some females will die before that, they'll get eaten, or they'll never reach a particularly large size and they'll never make that transition. It's only the largest and I guess you could say fittest of the females that ever actually become males, which is a really interesting evolutionary mode there. Pretty cool. Pretty cool. You know what else is cool is you, chat. For getting that right, $125,000 in your pocket. Let's see if you can double that to $250,000. You ready for that next question? I think you are. Let's do it.
And if dinosaurs had not died, I imagine that mammals would still be small creatures like this living in the nooks and crannies of their world, and we wouldn't be here.
I agree. 2Matt0, thank you for the follow. Welcome to Paleontologizing. All right. We talked about this on Wednesday for Alfred Wegener's birthday. Although Alfred Wegener is famous for his idea of continental drift, what kind of scientist was he? What was his field? Was he A, an astronomer, B, a physicist, C, a meteorologist, or D, a paleontologist? What do you think, chat? Do you remember? I'm seeing some C's in chat. All right. Chat, you seem pretty set on C, meteorologist. But how would a meteorologist come up with an idea like continental drift? Well, if you're set on C, I don't know, $250,000. That's a lot of money. Is this your final answer, chat? What do you think? Let's try it. Of course. Of course you're correct. Very nice. Yes, indeed. Alfred Wegener was a meteorologist by trade.
Why don't you just let it?
There we go. Remember this video from the other day? Really excellent. Gotta love this.
Hardly anyone in the early 20th century said, why are there oceans and why are there continents? Wegener is a wonderful example of how science benefits from people coming from outside a scientific field and saying, well, why don't you look at it this way?
And there you go, meteorologist.
Getting into a balloon and going up into the air for a meteorologist is like getting into a boat and going out on the ocean for an oceanographer.
He goes up in a balloon because he wants to take measurements of the atmosphere. He's not the Wizard of Oz. He's a scientist doing science.
Wegener flew as much and as often as he could. He wants to write the best book on the physics of the atmosphere, and no one had ever studied the atmosphere in the high Arctic before.
Anyway, he would later go on to come up with the idea of Continental drift. Yeah.
Office mate said, "Look at this beautiful atlas my parents gave me for Christmas." And he wrote to his fiancée, "Did you ever notice how South America fits into Africa?" Let me pause and say, there isn't a child on Earth over the age of 12 who hasn't had the same thought, right? You can see it. What was different about what Wegener saw? There were lines on the map that represented depths under the water, and they're exactly the same shape. That means that this is part of the structure of the Earth.
Anyway, really, really interesting insights there, and yeah. I had a lot of fun celebrating the birthday of Alfred Wegener with all of you on Wednesday, and I'm glad you remembered that. And his background was in meteorology. So, I'm impressed, chat. You really got that. That was no doubt in your minds, I feel. So you ready for the next question? There's no doubt in my mind that you are. Let's go for it. For $500,000... our second to last question is as follows. Which of the following is not a terror bird? Forrest Raked. This from our terror bird stream, day before Halloween. Is the answer A, Andalgalornis, B, Kalenkin, C, Titanus, or D, Diatryma? What do you think, chat? Which of these is not a terror bird? Will62 says D. Charlie's Dragon says D. And Chris TS says D. Murph says D. Machi says D. Amelia Bedelia says D. Well, well, well. We've got a fairly strong consensus so far. We've got no dissenting voices. D for Diatryma, says Golganek. Well, well, well. Are you sure that's a lot of money there? Big stakes here, big stakes. $500,000. Open notes? It is, Claire Bear. If you've taken notes, you're free to use them. It's open Wikipedia, too. D equals danger, says Dan the BC Man. Okay, well, chat, if you think Diatryma is not a Forrest Raked, if that's what you think, then we can go ahead and select D for Diatryma. But are you sure that's your final answer? Are you sure? I don't know, Diatryma looks like a big, fierce bird. You sure that's not a Forrest Raked? Well, well, well.
Hold on to your butts.
You're 100% correct. Yes, indeed. Diatryma. That famous horse-eating giant flightless bird. Not only did it probably not actually eat horses, at least not very often. It was probably an herbivorous animal. Diatryma, aka Gastornis. It's not a Forrest Raked. It's from long before Forrest Raked Day. And they are generally agreed to be related to Galloanserae, the group containing waterfowl and game birds. That's like ducks and chickens. This is basically a giant duck-chicken relative from shortly after the extinction of the non-bird dinosaurs. Cool stuff. Gastornis, aka Diatryma. Not a terror bird. Forrest Rakeds would come later, and they were carnivorous. These guys, probably not. Yeah, beak structure and isotopic signatures of their bones have caused scientists to reinterpret these birds as herbivores, probably fed on tough plant material and seeds. If you'd like more information, here is a link to the article. Oh, nicely done, chat. Very nicely done. You've got just one question left. Are you ready for the $1 million question? It's not going to be easy. Let's go for it. For $1 million, your question is, what is the genus name of the new Hell Creek pachycephalosaur just published in January of this year? Is it A, Spherotholus, B, Platytholus, C, Colepiocephaly, or D, Tylocephaly? $1 million on the line here. This is one that I forgot the other day. Which one is it? Blockman's Mustard says B. Claire Burr says B? Question mark. Chat pretty quiet here. Pretty quiet here. Murph says B was my first thought. Missed this stream, Chris TS? This was yesterday. We were talking about this. And, of course, in January when this was first published. Busim says that's a really hard question. It better be for $1 million. So far, I'm seeing some B's. Otter Do It says A or B. Why do you say that, Otter? Why is it A or B and not C or D? Yeah. Taylor says, I hope we get a song if we get this right. Well, shoot, we haven't gotten to our sub goal for the week. So, yeah. And we can't use a lifeline, Chris TS, not on the last answer, and not on the last question. What do you think, chat? What do you think? I'm seeing a lot of B's in chat. And I'm seeing a couple A's. Claire Burr will go with B. Let's get a few more people chiming in, and then we'll make our final decision here. Dinosaur Dave says B, final answer. You trust the mustard there, Lenina? B? And you like these tests? I'm glad you do, Amelia Bedelia. I think these are fun. Gives me a good sense for what people are picking up. What I might need to do a better job of teaching. B or D, so go with B, says Dan the BC man. All right. If you want B, Platytholus, chat. Is this your final answer? It'd be an awful shame to get all this way, to get this far and then pooch it on the last one. What do you think, chat? Final answer, yes? No? Platytholus.
Hold on to your butts.
Say yes. And you got it, chat. Very nice. Very nice. Very nice indeed. Platytholus was the correct answer. You won. And holy cow, Murph. You won and I won. And 20 chatters just won too. with those 20 gift subs, Murph. Holy cow! That is extraordinary, Murph. Thank you very, very much. Extraordinary. Thank you very, very much. Thank you for supporting Science Outreach here on Twitch. Thank you for helping put food on my table. Thanks for helping 20 people avoid the ads for the next 30 days. I know they appreciate you, Murph. Maybe almost as much as I do. Thank you very, very much. Holy cow. And yeah, we are only 23 subs away from our goal for the week now. But yeah, chat, Platytholus was indeed the correct answer. New species of dome-headed dinosaur identified in Montana. There we go. And this is, of course, from May 16th, 2023? I thought it was January. Anyway, but it is named Platytholus clemensi. It is named after William A. Clemens, Bill Clemens, a legend in vertebrate paleontology who was one of our elder statesmen in the discipline. And I was privileged to know Bill back when I worked at the University of California Museum of Paleontology when I was in high school. Bill would say hello to me every morning. It's wonderful that he's got a dinosaur named after him now, after he passed away a couple years ago. Another one of these dinosaurs is only known from one specimen. It's a skull dome, a skull roof, a classic pachycephalosaur part. So yeah. This new species shows that pachycephalosaurids were more diverse immediately prior to the end Cretaceous bolide impact than previously appreciated. And they may have had tiered niches in part by size, both of which have implications for ecological dynamics of dinosaur communities and a key part of their evolutionary history, the author said. And there's the paper in JVP. Good stuff. So anyway, congratulations, chat. $1 million. You won the game. Very nicely done. It warms my heart to know that you've learned these things and you're remembering them. That's that feels like a big deal. So thank you. Anyway, yeah. Fringe through that the dome supported a giant horn. I mean, I suppose it's not impossible. Casey Snowart, yeah. Maybe more likely on Pachyrhinosaurus than on Pachycephalosaurus. But yeah. So we just send you our Venmo or Cash App? Oh, the check's in the mail. A David P. Glass. Check's in the mail. Don't worry about it. Are you ready for ejecta as an answer? Oh, I totally forgot that, HD and HB. Yeah. I know we talked about that. It slipped my mind when I was writing the questions this morning. Anyway. It's time to wrap up today's stream. So let's do it. Thank you, everybody, who helped contribute to making this stream a wonderful one. I really appreciate it. To everyone whose names are appearing in the credits. I never know how to say that properly. Thank you. From the followers and the lurkers, to the raiders, to the gifters and subscribers, to the cheerers and the moderators, I appreciate you all more than you know. Thank you for helping support me. Thank you for making this another fun episode. And we are going to go right into science streams here. And we're going to go see what Balint has to say about some science news from the week. So we got a damselfly on the screen right now. Very cool. Well, I hope you all have a wonderful weekend. Thank you again for your support. Thank you for helping me do what I do here. It is an honor and a privilege to be able to bring fossil science to all of you every weekday. So all of you enjoy your weekends. Take care of yourselves and each other. And we're going to go see Science Streams. See what Balint is up to. And pass on the science love with a raid. See you there, everybody. And I hope to see you on Monday for another exciting paleontologizing stream. Take care, everybody. Bye-bye.